Philippe Vincent Lazaro, Senior Dam Specialist, World Bank. Thank you, sir, for being here with us. Mr. Madhava from Messrs. Dinosaurs, Concrete Treatment Private Limited. Ladies and gentlemen, please keep the applause going. Engineer Satish Kumar Singh from ULVNL Limited. Engineer Saurabh Sharan from CWC and Mr. Sunil J. Pillai from CWPRS. Well, with all our panelists here on stage, I hand over the session to our session chair to kindly take it forward. Thank you.
Thank you very much. And I must tell you that you're doing an excellent job making sure that everyone is appreciated for their presence and participation. Good morning, everyone. Welcome back to day 2. And as the panel is assembled here, I wanted to say a few things before we start. First, I think yesterday was really an outstanding day for me, listening to all the speakers and the presentations. And it just tells me how much knowledge we have in this country, in this room, and you working on these issues across the country, and of course the experts who are here from the World Bank and other countries. And this knowledge exchange among practitioners, experts, academic, and the institutions like us who are investing big time in water security and sanitation around the world is extremely important. And I really commend Government of India actually for taking this initiative. The second point I wanted to make is that clearly there is enough evidence that dam safety will have to be a core priority as part of our water security agenda in the countries around the world. It cannot be a sideshow when you talk about water security. It has to be very much central to our water security agenda. And clearly, many countries, I would say, including India, have already taken the initial step, but we have a long way to go because it's just that the size of the problem. I mean, if you have 6,000 dams, you've done about 700 dams, you just have so much work to do. And this will take time. This will not happen overnight. But I think once we create the ecosystem and the partnerships and we have the knowledge, I think it will continue moving forward. One challenge I see is how do you finance this and how do you maintain this, this kind of investments? Not many countries are able to finance these assets and their operation and maintenance. And it'll be very easy for us to say, well, the ministries of finance need to find money and create a budget line for O&M of the water infrastructure assets. But remember, the same Ministry of Finance are getting the same message from all the line ministries and all the agencies, and resources are limited. But the governments need to prioritize public finances. And one idea that I have raised with some of our colleagues today morning, that we got to be better at economics of investing in dam safety. That a dollar invested or rupee invested in dam safety helps in avoiding the unfortunate consequences of failed dams by 100 rupees, 500 rupees. And that really establishes the cost and benefits of that investment. And we at the World Bank, because this is our core mandate, the economic analysis, we are thinking of initiating such a study as a follow-up to this conference, which can feed into the future conferences and knowledge exchange events that you'll be organizing. So with that, we would like to begin the day 2 session. We have 6 presentations and 10 minutes max for each presentation. There will be an early warning when your time is only 2 minutes are left, and there will be a final warning before the 10 minutes. I've asked Sataru to be the timekeeper and make sure that we are running according to the clock. Because I trust the Japanese sense of time, and is my dear colleague. He leads our dam safety agenda at the World Bank in my department. So he's kindly agreed to do that. Thank you very much, Sataru. So we have 6 presentations. I'll quickly introduce them, their title and where they come from. So the first presentation is by Felipe Vicente, Senior Dam Specialist at the World Bank in my department. We will then turn to Sataru, who's the lead dam specialist, head of our global dam team in the World Bank. It will be then followed by a presentation on Karnataka experience by a number of speakers. I'll mention their names when the turn comes. But why don't we start with Felipe, you first, and then I'll introduce other speakers as their turn comes. Over to you.
Thank you, Saroj. Good morning. I will give you a quick look at the World Bank dam portfolio, and then I will focus on the rehabilitation of 2 projects in Africa. Over the last 2 decades, the World Bank has supported more than 400 dam-related projects in more than 70 countries. You can see that it's a large portfolio with more than 2,400 dams, mainly for rehabilitation upgrading in Asia, Africa, and Latin America. The total commitment of the World Bank in this project is around 67 billion US dollar, which include all components of the project, not only the dams. This slide displays a list of complex dam rehabilitation projects ongoing and recent. You can see clearly our 2 drip projects, but we also have other projects with a very large portfolio of dams, hundreds of dams, projects in Vietnam, Indonesia, Sri Lanka. But we have also smaller projects with 1 dams or a couple of dams. I'm involved in 2 important projects in Africa, the rehabilitation of Kariba Dam and the heightening of the reservoir of Korumana Dam. We have the operator of Korumana Dam here in the room. For the location, Kariba is built on the Zambezi River between Zambia, Zimbabwe, and Korumana is in Mozambique. The Kariba Dam, the construction was completed in 1959. It is important to know that the 128-meter high arch dams impound the largest man-made reservoir in the world with a capacity of 100,000 million cubic meters. The purpose of the dam is hydropower. We have a power station in both banks and with a total capacity of 2,000 megawatts and a power generation more than 10,000 gigawatts per year. The 300 million rehabilitation project supported by the bank, but also other donors, aim at improving the safety and reliability of this dam with 3 main components: the reshaping of the plunge pool, the refurbishment of the spillway, including the installation of an emergency gate, and the review and update of the emergency plan, including installation of the early warning system. It's hard to imagine that the flood spillage has eroded 80-meter deep hole at Dam 2. And as you can see on this picture, the erosion is going backward. I mean, in the direction of the dams, and this raises serious concern on the safety of the dam. Interim remedial measures have been implemented so far with the no opening of 2 adjacent gates. This means that we use 3 out of 6 gates to manage flood, and combined with that, the lowering of the rule curve by 3 meters. And this has a huge impact in terms of power generation, because you have less head and less volume for energy production. The reshaping works consist, in fact, in increasing the volume of this plunge pool. in order to have more space for energy dissipation, but also to guide the flow toward downstream. The execution of these works that require the excavation of 300,000 cubic meters of rock require the installation of a temporary cofferdam and the full dewatering of the plunge pool. You have to imagine that we will dewater 80 meters at the dam 2. Here, another view. You have the dam on the left with the spillway. On the right, you see the temporary cofferdam, also the outlet of the 2 powerhouse. Important to mention that the works have no impact on the normal operation of the powerhouse. And you can see the shape of the new plunge pool. This geometry of the plunge pool was optimized based on numerical and physical model, where the measurement and the result of the physical model allow refining the parameter of the numerical model. Some picture quickly, starting with the construction of the cofferdam. The pier were built on the bank and floated into position and filled with concrete. On the right, you have a view of the dams after completion of this cofferdam just before starting the watering. On the left here, you see the current plunge pool. And on the right, start of the work with the access road. The excavation are going on and should be completed by February next year. The consultant have developed a sophisticated finite element model that simulate all the different stages from the watering and excavation. From an engineering perspective, the result is a bit disappointing because the model shows that this work have no impact, or very little impact on the dam behavior. We have only 1 or 2 millimeters deformation at the dam crest. It's a good news for the project, but from an engineer, we expected to have something much more complicated. We have also a robust dam monitoring in place to monitor the dam, its abutments, and the cofferdam. The dam behavior is complex, depending on the upstream reservoir level, on the temperature. But as I said before, the works downstream, water level, and excavation have little impact on the dam behavior. The behavior today is satisfactory. There is no concern about the safety of the dam. The second component is the refurbishment of the spillway and installation of an emergency gate. These works are required by the fact the concrete is affected by an alkali aggregate reaction, leading to deterioration of the concrete around the spillway and also misalignment of the build part. To execute this work, there is a need to install a 30-meter high needle cofferdam upstream. You can see the current situation. The contractor is working in 3 sluices. We have always 3 sluices available to manage flood. The second project is about Korumana. This 53-meter high, 3-kilometer long dams was built and completed in 1989. It's a multi-purpose dams, mainly for irrigation. To mention that the original project included the installation of gates on the spillway, but due to lack of financing, it was not done. It means that for more than 30 years, the dam was operated with a level 6 meters below the full supply level.
2 more minutes.
It's perfectly fine. As said, the World Bank project financed the installation of these gates, the construction of a saddle dam with an emergency spillway, and the upgrading of the monitoring system. The installation of the gates will allow raising the reservoir and to gain 500 million cubic meters. Some picture of the installation of the spill and the gates. And finally, just to mention that this work required the displacement of 130 families. And here you have some picture of the houses and facilities constructed under the project. I thank you for your attention.
Sorry for putting that time pressure, but you finished on time. All the speakers to follow, if you could really emphasize what is a good practice in the case study that you are presenting, because I think that's relevant to the audience. Because everything that you presented is great, but I think it's very important to inform the audience what you think is the emerging good practice in the two case studies. So next we have Sataru Veda, who is the head of our global dam teams in the World Bank. He has 10 minutes, and to avoid conflict of interest, I'll be keeping the time for him.
Sorry. Okay, slide is uploaded. Okay. Good morning, everyone. Thank you very much for giving me this opportunity. And I'm very pleased to be back to India. And first, I'm going to introduce the good practice note on dam safety very briefly, which provide guidance on how to apply this risk management approach and identify priority mitigation measures for bank-funded projects. And I will introduce several cases of the existing dam, the rehabilitation and upgrading. Good practice notes provides guidance on this dam safety requirements and risk management approach and the tools in the context of bank's project and application to bank operations. Also, we have issued the technical notes, 7 technical notes, including hydrological, geological risk, and so forth. And then also particular potential failure mode analysis, and also a portfolio risk assessment with risk index, again, and in the context of our client countries. I don't have to explain this but I follow this risk definition according to the international standards. So it's very clear. We highlight the likelihood of failure and consequence in case of dam failure or misoperation. So I just, yesterday, Dr. Gupta talked about this dam's risk classification system. So again, I will not repeat it, but just want to emphasize this classification system needs to be developed in a tailored manner to the different countries, considering their type of portfolio and also this national regulatory framework on natural and social conditions and so forth. This is important for us how to apply this risk management approach to different types of projects. The required level of risk analysis is recommended considering 2 key elements. First, it's the risk level on the vertical axis and knowledge level on the horizontal axis. And as risk level increases, more advanced tools need to be applied. And the tools become more detailed, the level of knowledge and information must also increase, and suitable technical support should be considered. The scope of any analysis needs to be fit for purpose and informed by the context and decision-making needs. This slide shows the basic concept of portfolio risk assessment using risk index as an initial screening tool for a large portfolio of existing dams. Typically, the risk is composed of risk category and the potential hazard or downstream consequence. And risk category is composed of 3 elements: score for technical type, design flood return period, and so forth. And then existing dams condition, such as this the seepage, the deformation, and so forth. And then dam safety plan, which covers this organization structures, instrumentation capacity, and so forth. This slide shows some example of this risk index application to existing dams. Left-hand side slide shows this the original risk profile, and then the reduction of risk by non-structural measures and structural measures, and then blue indicates the residual risk for each dam. And then we also applied a similar type of risk index for large portfolio project in Vietnam and Indonesia. And the projects that have been dammed projects have been identified as higher risk should be subject to more advanced risk assessment tools, such as potential failure mode analysis. This is originally, as you know, this was developed by FERC, US FERC, but this is one of the basic but effective qualitative risk analysis. So we have applied this for some important projects and found this quite useful in identifying this most credible failure risk, failure modes, and priority remedial works. Here's an example of some PFMA application, including this Nulek in Tajikistan, and also Jatifu in Indonesia, Kaliba, and so forth. And also some bank-funded program provided assistance and training for risk assessment using PFMA for the Eastern Nile and so forth, with international experts. In addition to dam safety, as Saroji talked of yesterday, we issued a publication on global storage, and in particular, we introduced a concept of 5 Rs, and in particular, the rehabilitation, reoperation, retrofitting, important for existing dam rehabilitation and upgrading. And we have prepared and are going to issue a new note on getting more from existing dams, a catalog, including nearly 50 facts, and introducing different types of intervention for retrofitting. For example, this adding functionality to existing asset, say for renewable energy, installing the solar panel in the existing storage, or this low-head mini hydropower for existing irrigation dam and so forth. And for reoperation, the enhancing performance of existing asset, introducing advanced rainfall flood forecasting system and decision support system for optimal reservoir operation, which would enable this enhanced flood control, water supply, or hydropower generation. We also have prepared issuing a new note on the climate change impact assessment on extreme hydrological events and the resilient enhancement measures for dam safety. Building on this guideline from ICOD and IHA, and then uses a bottom-up approach, and also high-risk cases involving unacceptable outcomes is the further detailed evaluation that will be conducted using advanced techniques in a proportionate manner to potential risk. And this note provides a comprehensive review of adaptation and the resilience enhancement measures against the climate change impacts on extreme flood events. Now, I quickly introduce 4 cases. First one, enhance the inflow forecasting and reservoir operation system under the Malawi Shale River Basin Management Project. And Kamuzu Barrage is a cornerstone for regulating the water level Shale River system. And then this project has rebuilt this weir, but also importantly, introducing the new operation decision support system for optimizing the reservoir operation for water supply, high power generation, flood control with 5 release strategies. We also applied the similar approach for this Sitram River in Indonesia, Tuban River Basin in Vietnam. This is a case for Albania Green River Hydropower Cascades project. The project provides funds for conducting PFMA and executed the priority remedial works, including renovation of the mid-level spillway gates and the operation system, which enhances the reservoir operation system, and also slope stabilization, downstream toe protection foundation using jet grouting, as you see this picture before and after for Komani, and then to improve the safety monitoring system, or EPP. And then we also provided funds for Ukraine hydropower rehabilitation for Dnipro hydropower cascade dams, in addition to this renovation of hydropower generation system and rehabilitation of civil structures. The project supported the installation operationalization of integrated dam safety monitoring system with remote data acquisition system connecting all hydro dam and the Ukraine Hydro Energo head office. We're concerned about the current safety condition of those dams, but we hope to provide re-engage for the reconstruction of those facilities in the near future. Lastly, remote safety monitoring using satellite imagery in the case of Lake Salez in Tajikistan. Lake Salez was formed by the natural dam, formed by earthquake-triggered landslide. The project provided critical monitoring system for slope conditions. Otherwise, it collapsed into the lake, and it could create and that could threaten the safety of the dam. The last slide, this shows a range of collaborative opportunities between India, World Bank, and international experts, including advancing risk-informed approach, enhancing resilience adaptation of existing dams, advancing rehabilitation, retrofitting reoperation, and also provide an institutional support on capacity building for effective dam safety and storage management. Thank you very much for your attention. I'm sorry I must have taken extra time. Thank you.
Thank you very much, Satoru. And just to keep the discussion going, and before I invite the next speaker, I'm wondering whether the use of word rehabilitation is really appropriate in the current context. I think we would need to search for a new terminology, possibly making our dams more resilient is perhaps the better way of defining what we are discussing here. And the second is the combination of Earth observations, new climate models, new hydrological models where our infrastructure is created, such as dams, and how do you operate it so that the dams remain safe, secure, and resilient is something we will have to basically, I think the dam community of practice will have to really bring that knowledge into the way of working, because I have a feeling sometimes that we seem to assume that we are in a very static hydroclimatic situation, which is not the case. Many events which we thought was 1 in 500-year event is possibly becoming 1 in 50-year, 1 in 75-year events. And unless we bring the latest climate models to develop our new hydrological models, I have a feeling that you would be investing in making your dams resilient, but there could be under-adaptation or maladaptation, in my view, in the investments that you'll be making. So I think we should really think through this more carefully based on my reading of the presentation you made. But I think we would welcome questions on this later on. Let me turn to the next speaker, Mr. Madhwa from the Dinosaur Concrete Treatment Private Limited. And the presentation they will share with us is on underwater pointing and grouting of 100-year-old Krishna Raj Sagar Dam from Karnataka. Dr. Madhwa, floor is yours.
Thank you, Chairman. So good morning to all. So first of all, I wish Happy Engineers Day to all. So now I am presenting the underwater pointing and grouting of 100-year-old Krishna Raj Sagar Dam, Karnataka. So I got two authors are also with me. So this brief introduction about the KRS. I need not to go all the details. It is a multi-purpose dam, and it is conceived by Sir M. Visvesvaraya Bharatratna, known for his foresight, grand vision, and conceived the project. Started in 1911 and completed in 1932. And this is one of the dam carried only with the labor and less machineries with local materials. This is the speciality of this dam. And this dam is built using traditional stone masonry and a lime pizzolone mortar to act as a binder. And this dam is among the first in the world to use automatic gates and represent the marvel of civil engineering of pre-independence India. And this is the dam who constructed this Brindavan garden. This was the dam shown to the world. The waterfront can attract the tourists. Even today, this is the role model. And using this, I think, multi-purpose dam, I already explained. So 1901, the electricity was generated the first time in Asia. So coming to this, the actual what we have done in KRS, 100 years old dam. So this is the DSRP broad observations, sweating on the downstream phase masonry portions. So this the dam, one issue was there because when it was constructed, there was no drainage gallery. So there was no proper measurement of the seepage. So this is what we observed, the DSRP team has observed. Leaching of pointing water at some places, and springs of water and downstream phase at chainage 2120 meters. Damages in seal coats at the gates leading to leaking through these seals. Peeling of the mortar in masonry joints of apron with pitting of the surface. Distress on downstream phase like deep and wide openings between the adjacent masonry. These are all the broad observations. This was the visible sweating on the downstream side of the dam. So these are the suggested studies for diagnosing the cause of the distress. So except last one, all other the studies were conducted and carried out in the DRIP 1 project. So we have successfully completed the upstream pointing above the MDDL, and also successfully we erected the 136 100 years old gates. I think SCADA is the only pending issue, so it is put into the operation. So below MDDL was our issue. So then we introduced this, the ROV came into our help. So remotely operated vehicle survey and investigation of the underwater upstream surface area below MDDL minimum, the drawdown level. So these are all the broad observations by the survey investigation. So the vertical and horizontal joints between the masonry stones were seen, widely open to an extent of 50 mm or even more. And there was complete loss of pointing mortar. The depth of opening in the masonry joints was observed to be about 500 mm on average. There was presence of debris at the bottom. The total area of loss of pointing mortar was 6,400, roughly around 7,000 meters square. And also the underwater videography done on the upstream surface between the two chain edges, so the gorge portion what we are talking, indicated that the pointing mortar has been lost, distressed, or delaminated in many places, making the masonry joints open, susceptible for leakage or seepage. So this is the ROV, the observations. So different chain edges, entire chain edge from 800 to 2,120 meters we have carried out blockwise. So those are the red portions showing the loss of mortar. So this is another way of representing the loss of the mortar in the masonry joints. So this is the ROB videography, what we have taken for the entire surface we have taken. You can see the joints, the mortar has lost. So all the entire area we have captured like this. So this was entrusted under the DRIP 2. We have taken up this project and entrusted through the tendering process to Mr. Dinosaurus Concrete Treatment Private Limited, a well-versed, experienced contractor. What methodology we have followed? So erection of the hanging platform to lower the divers and the material, cleaning up the surface, raking and cleaning up the masonry joints, fixing up PVC nozzles for injecting grout for filling the internal pores or voids in the side stone masonry, sealing up joints, there is flush pointing with high strength cementatious material conforming to this R4. This is the standard procedure we have followed. This is the joint earlier before the mortar was filled. So this is diagrammatically we can show 7.5 centimeter or more raking we have carried out. No, not 75, sorry, it is 7.5 centimeter. This is the first step. Next, you can see in the video we have captured everything. So how we take the raking we have done. It's the right side. You can see the visible raking of the joint. So next, what we have done, we have inserted this nozzle. So about 20-30 centimeter after the 7.5 centimeter raking. So this is the nozzle we have inserted in both the places. So once the nozzle is fixed, so it was filled with the cementitious material, conforming to this class R4. This is what we have done. The flushing of the flush pointing. So this is red shows the grouting material, and the green shows the cementitious the flush pointing. So this is underwater flush pointing masonry joints. So these are the materials, cementitious material conforming to BS and EN 15043 class R4. So these are all the strength parameters: compressive strength, chloride content, adhesive bond. So we have the material was tested in the laboratory, and after we receiving at the site, again we have given to the NABL accredited lab, and we have tested. See, after the material use also we have tested, we have confirmed the results. This is the underwater masonry joints are pressure grouting. So we have, the pressure grouting we have carried between the 1.5 to 3 kg per centimeter square. So cementitious material and underwater microconcreting we have used. These are all the strength parameters. So this coming to the conclusion. So now based on the DSRP recommendation and findings of the remotely operated vehicle survey, the underwater upstream phase surface, area pointing and grouting with the latest technology and materials to arrest the seepage and strengthen the safety of the dam has been taken up. The second one is very important. Correct assessment of underwater grouting quantities required during the preparation of the PST. This is what we are facing in the KRS dam. What we have made provision in the PST, but the consumption is very high compared to almost 5 to 6 times. It is taking this the grouting material. This is one we are facing. The work is executed by an experienced agency. So all these quality properties is utmost important. We have monitored. The sweating and springs of the water absorbed in the downstream of the dam before rehabilitation is completely arrested, and the upstream phase pointing body grouting after the upstream phase pointing and the body grouting. Yeah, thank you.
Very good on timing. And I had a question for you, but I will go to the audience first on the remotely operated vehicles, and how is the use of artificial intelligence going to make the ROVs more efficient, and in terms of the cost efficiency as well. But let's go to the audience and see if we have any questions for the 3 speakers so far. And I'm sure there will be mics somebody can help me with the mics. I see a colleague gentleman here has raised his hand. Here in the front row, please. Hey, somebody's bringing the mic. If you could also introduce yourself and then be brief with your question, please. Thank you.
Myself, Dr. Dumar, Chief Engineer, WRD Maharashtra. My question is regarding Krishnaraj Sagar Dam rehabilitation. How much was the earlier seepage through dam and after grouting work, pointing? You mentioned that there was no sweating, but is there any terminology like Lugan value or liters per second? Like?
So unfortunately, there is no provision to measure the seepage since we don't have a drainage gallery. But what we have done during the sampling, the borehole, the test, what we have conducted, where the Luzon values is more than the permissible limit. That is the only indication, and the sweating is another indication. If it is a drainage gallery, there is a V notch, we can measure the seepage. Unfortunately, it is not there. So by visual observation, that is one. And Before start of the work, we have conducted a trial hole and we have conducted the permeability test. So it shows more than 10 to 20 loosen values. So we went for the dam body grouting and also upstream treatment, dry the above MDDL. Now we are doing below MDDL. So two way we are arresting the seepage by way of grouting and another is upstream treatment.
Grouting also done.
Huh?
Grouting was also done there.
Yes.
Okay. So both upstream treatment and grouting was executed. Thank you, sir.
Oh, thank you. Okay. A gentleman in the third row. Please go ahead. But also there's a question there. Up आइए पहले हाँ.
Basant Maheshwari from Western Sydney University. So I heard about the risk assessment, especially from Sature and other people. So there is a physical risk for the dam, but there is a risk to human life, livelihood, gender, and all other aspects. So how do you account for those things along with the physical risk?
Thank you very much for this question. I think we pay much attention to the consequence assessment with regard to the impacts on people and also economic and the social activities, in addition to this structural risk analysis and so forth. So this is an important part of this risk classification, and then accordingly suitable level of safety is secured by this implementing the suitable remedies. I hope that is that the question? I hope.
Sam Banzi, I'm from Australia. A couple of questions for the World Bank. You showed your cost profile where you're actually spending a lot of money, and a lot of money is going into rehabilitation, and when we change the terminology to resilience or something, and there's a little bit of money going into precautionary type activities. What's the World Bank's thinking around that in terms of driving better practice where dam owners are investing in doing some of those good practices that help them to extend the lives of the dams so that they don't have to spend a lot of money on rehabilitation where it makes sense to do so. And the next question is more around the value and the benefit realization. I think there was a presentation around how the World Bank is applying risk. Following up, I think, from the question that has just been asked there, how is the World Bank actually demonstrating benefit realization from risk reduction, if anything, when you're making your assessments on investments? I hope that makes sense.
Yes, sir. We present this result of this reduced risk by the structural measures and also non-structural measures. In particular, we work with the clients for working for this operation, the maintenance aspects, and then also the contingency plan, emergency preparedness plan, and so forth. I think it's one of the challenges is really the securing this financial and the institutional support system for sustainable operation and the maintenance, and then ensuring this the long-term safety. I think I hope I understood your question there.
Three things I wanted to mention. First, on the factoring human cost in the risk assessment, even one human life, if that is at risk, it is too much from an investment point of view, and that can never be compromised. No risk assessment. Most of my experience has been in the risk management area, and the way we approach this is that first, when you do the risk assessment, you really understand the hazard and the vulnerability and the exposure. And if it involves human element, human being coming in the harm's way, either you basically mitigate the risk to zero, which is impossible, or you have a very strong early warning and emergency preparedness mechanism, which is where evacuation comes in, which is where safe shelters come in, so that you basically reduce any human consequence of a natural catastrophe or any other man-made event. But there's no way you can put an economic value on the human life. I think that is not what the risk managers will ever do. They will create mechanisms so that no human life is lost as part of a comprehensive, what I would call response mechanism in these cases. It applies, same approach applies to dam safety assessment as well. I mean, if you see the cases around the world, naturally, each dam safety, when you prepare the emergency action plans, you clearly look at how many people are there in the harm's way, and what is the alternate route for evacuation, for safe shelters, and how many times you will do the mock drills and exercise to literally evacuate people. So all this comes as part of a comprehensive response. In terms of your question on the World Bank investments, we are a manifestation of what the governments are going through. In the World Bank, do you really think water is a priority? It's not obvious to us. Among the 14 sectors that the World Bank is engaged, when I got this job last year, I was wondering, I thought water should be the most important thing the World Bank should be doing. Guess what? It is not. Because the governments don't come to the World Bank asking for water sector investment. So if you don't ask, governments don't ask, why will the World Bank come to you and tell you, oh, you should invest in water? And I think in the whole climate negotiation, we are in COP28. Water is mentioned as a small para in the Sharm el-Sheikh COP27 to say, oh, water is important for the adaptation agenda. That's it. A word is mentioned. So clearly we are failing policymakers, international community, private sector, scientists, everyone. The IPCC reports are much more definitive on consequential issues in the hydrological cycle because of climate change now than before. The IPCC reports themselves have been very fuzzy and not very clear in terms of what it means to the water cycle. There's a lot more scientific evidence now than before, but there's still the awareness among the policymakers, ministries of finance and planning, it is still lacking. And I think the more people understand, the climate crisis essentially is going to manifest itself through water crisis. Too much water, too little water, too polluted water. And unless you really address that through better planning, better investments, like things like this, you're not going to be able to deal with this issue. And so I think you'll see a World Bank in the coming years, and my team will tell you, currently we do $5 billion per year, and I have told them, we have to do $20 billion from this year. Anything less than $20 billion is a failure. Because if you don't fix your water assets in the world, better early warning system, better flood management system, better drought management capabilities, we are going to be not serious, really. So it's not about cheap money. It will take money to fix the problem. So let's be really serious. And I think everybody who's in this room responsible for policy making, I think when you go back home, tell your ministries of finance, this is not cheap. They will have to start investing. If you use your own public finances, but also take money from others who can help you to really start fixing it. It's not going to be cheap. Tell your planning commissions, planning board, and Niti Aayog and the likes. Anyway, all this to say that what you saw in our portfolio is very underwhelming for me as World Bank director for the practice. And I tell my bosses the same. When I briefed my president, I told him exactly the same thing. That if you're really serious about water security, this is going to take 5 times 5x to really start making some difference. But the governments will have to do a lot more than what they're doing now. So you got me started by asking this question because I'm very passionate about what I do. And I will not be doing something which I don't enjoy. And I think we are not very serious. Only country, India is one of the very few countries which is serious about water. And that's why I come. This is my country, but I commend this country because you are really doing a fantastic job. And Other countries need to learn from this country. The political leadership, the commitment to make things happen is amazing in this sector. And I give this example when I go to Nigeria, Ethiopia, Ghana. We always talk about India's example of how water can become a political agenda, an agenda for change, agenda for economic development, agenda for prosperity. But anyway, please don't get me started on this point. Okay, we'll turn to the next. Can you wait for a few more presentations and I'll come to you? I've taken note of 1, 2 hands here.
Okay.
You see, I'm asking somebody to keep time. I'm not keeping track of myself. I need to control myself. Sorry about that. Okay, the next presentation is by Engineer Satish Kumar Singh. And he will be presenting curtain grouting and cutoff trench along upstream right bank of Joshiara Barrage of Maneri Bhali. Stage 2.
Namaskar to all of you and happy Engineers Day also. So my presentation is on our one of the project Joshiara Barrage. It is under operation from 2008 and then it is a 12-year operation and it is run of the river scheme on river Bhagirathi located in district Uttarkashi of Uttarakhand, upper reaches of the Himalaya. There upstream is the dam of Maneri Dam upstream of this project also. This project is very economically very good project. It have around 1300 million unit generation over the year. And the main problem of this, this is our brief history of the project, which I've just summarized in this. The power plant is located around 30 kilometers downstream of this project, and it has a 16-kilometer headrace tunnel. This is our plan of that Joshiara Barrage. On left bank, this is Joshiara village on the name of this project. And on the right bank, there is a Gyansu village area. Our Gyansu village area is just many of the houses are located around this bank. And this is also 50% area low-lying area. Low-lying means the level of this area is somewhat below than that the FRL of the reservoir. Earlier, when we operated the project in 2008, we operated for 10 years at MDDL level because some of the protection work upstream of that project was pending. After completion of this, we have just raised our reservoir level up to FRL and started more generation. Then we have observed a serious problem on the right bank area, that water seeping around the cultivation fields and houses of the villagers. They are making complaint that in house the water is emerged out in their rooms, floors, and their septic tanks, everything become choked throughout the operation, and they are forcing us to not raise the level of the reservoir. This as it is a continuous project and generation was required, so we have started to envisage how we resolve this problem. This is the right bank area. You can see that cultivation fields also, and every time they are waterlogged throughout the operation time, and houses are located there. Okay, this is the main our plan and how to. You can see that the major problem is that the right bank is of nature of the strata right bank. It somewhat RBM nature. The bedrock is located about 35 meter deep, and it is the geological section of that present key somewhat. As we move up from barrage axis to upstream, the bed level goes on, rock profile goes on down, and the water seeps around. As we raise the reservoir level from MDDL to FRL, the pressure had increased and water just to go emerge out on the right bank side in cultivation field and houses of the residentials. The existing cutoff trench was not so deep to trap the entire seepage of this. So we have planned to combination of that. We also referred this problem to various experts also. The DSRP team came and geologists have also recommended to few of such type problem. And we have selected like deepen the already existing cutoff trench and provide the relief wells at some locations and sewer line, installation of sewer line. Many of solutions have been given, but we have adopted to, out of this, we have adopted combination of these two. This one, the recommendation, first one recommended by the DSRP team, you will construct the just curtain around the 300 meter, the problematic zone, and adopt also the construction of deep cutoff trench. Cutoff trench is also very necessary because it is a hilly region. So various natural drains also meets to the river and through the village. So trapping of that was also necessary because if we make the curtain grouting along the reservoir, but on the right side, if some natural drains are coming, trapping of them is also very necessary. As this project was executed under DIF phase 2, technical guidance we have obtained from the CPMU and DIP also, and they have helped a lot of us to. So before execution of this grouting, because the data was not known to us, we have taken out many of the investigation to do our curtain grouting work, like electric resistivity test, cell potential survey, and seismic inspection test. These tests also very common today also to know the profile of the strata and saturation zone where it is less or more, so that we are confined ourselves at that point also. And we have done the drilling core test also for the purpose of core purpose to see the how actually rock nature and how grouting will be required, depth of rock. Permeability test we have taken out at least 3 vulnerable locations to know the permeability of the soil, and groutability test also performed by triangle method by the way of equilateral triangle. On the vertices of we have just primary holes executed at the vertices of that triangle, and then we have checked the central hole to how it is effective that. This is the finding of our ERTSP test. It is just say about what is the zones of saturation, so that we can confine ourselves, or we have more grouting could be done at that
2 more minutes, please.
location. And this is also findings of the seismic section to bed level. What is the stratification of that bed levels? We have, because zone was very poor, so core recovery was not so good. This we have performed the permeability test at that location by the standard method describing in the IS code to know the permeability of the existing strata, which is very poor. Groutability test performed at 3 locations with the help of drilling and grouting. We have, with the help of geologists, they have recommended on the basis of strata, they have recommended some types of combination of grout mix design, and the basis of location we have just executed these designs at the time of, and they also just put the pressure should be limited, not so high, so that hydraulic fracture should not be there. This is just some pics about how we have executed this grouting operation using, because overburden was such time. This is, yeah. This is execution of site official also, and it is finally execution of 2-row grout and curtain we have imparted, and now the Our area is completely dry. Cut-off trench is working properly, function. Yeah, this is a plan of our execution. Downstream, we have executed this cut-off drain. This is our execution on. Yeah, and also villagers are also confirmed that now, sir, problem has been resolved and some balances work are to be done for them. Yeah. We have conveyed a lot of thanks to World Bank and CPMU to provide assistance in this.
Thank you. I like that testimonial at the end, all is well that ends well. I guess that's a certificate from some committee that saw your work. Next presentation is by Engineer Saurabh Sharan on issues and remedial measures under the Dam Rehabilitation and Improvement Project.
Good morning to all dignitaries on the dais and off the dais. My topic of presentation today is Dam Rehabilitation in India, Best Practices and Lessons Learned under World Bank funded project, DRIP. Yeah, this slide shows the distribution of dams across the world. Basically, India is ranking third, which we all know that around 6,000 dams are there. And dams are equally important, and they are playing critical role for the growth of our country and economy. This shows basically the safety is of paramount importance to us, and we are facing various safety concerns like dam aging and deferred maintenance. Then there are changes in the design practices, and also climate change is adding stress on our dam infrastructures, and also these are posing hazard to the downstream community. So this shows about 50% of the dams are more than 25 years of age, and out of that portfolio, 108 dams were taken under DRIP. As part of the preparatory activities, these are the three important preparation stage works. First is the design flood review of the dam, in which hydrological safety is being reviewed from the change in the design flood perspective. Then there is a dam safety review panel, which is being constituted by the state governments. They can carry out the dam safety inspection of the given dam. And based on the outcome of these two inspections and design flood review, a detailed project screening template called detailed project report is being prepared. Coming to this slide, these are the stepwise what we have done in DRIP phase 1. The steps are like the most important steps are design flood review and design inspection by DSRP panel. And based on that, recommendations for the rehabilitation are worked out, and financial provisions are worked out. And based on the World Bank procedures, the tenders are being invited and awarded. This is about the design flood review. We have Indian standard codes for checking which category of design floods will be there. So it is classified as per the gross storage and hydraulic head. And after carrying out the analysis in DRIP 1, we found that majority of the dams were exceeding their original design flood. And also due to the change in the design practices, like 40 years back, we didn't have the concept of PMF. So after these were carried out, we found that majority of the dams were exceeding the inflow design flood, original inflow design flood. And subsequently, flood routing studies were also carried out. And it was found that about 51% of these dams didn't have sufficient freeboard. Coming to the inspection by the DSRP panel, these constitute review of the available information from the project documents. And they carry out the inspections based on the pre-monsoon and post-monsoon inspection reports and discussion with the project officials. And then panel advises on the complicated dam safety matters and critical aspects of the project. And they also recommend the remedial measures on various safety concerns like hydrology, seismic safety, or structural safety aspects. This is the outline of what our project screening template contained of. Based on this assessment, the project details, which was description, location, and benefits, dam specific details, health status of the dams, and complete rehabilitation proposal. This is talking about based on the pre-ST, we categorized our dam rehabilitation works into 4 categories majorly. These were addressing hydrological and operational safety, the seepage concerns, stability issues, and basic facility improvement. To address the hydrological safety concern of our structures where inflow design flood, revised inflow design flood was exceeded, we carried out certain interventions to address those hydrological safety concerns, like providing of upstream solid parapet wall, then repairs of spillway conveyance system, then additional spillway also were provided in few dams. This is the typical example. We have I have just quoted some example. Like in Manimukta Nadi, the design flood review was exceeded by 400% times, means 926 to 3356. And to ensure the safety, hydrological safety, additional spillway on the left bank was provided. And fuse plug is also planned on the left abutment of under this new drift phase 2 and phase 3. Seepage is another issue. We have seen excessive seepage in the embankment dams and machinery dams. And we have also seen dampness at the downstream phase and in the galleries. And in embankment dams specifically, we have seen seepages with coming out with fines due to the internal erosion problems. And certain cases, we have also witnessed boiling at the downstream phase of the dam. To control these seepage issues, we have taken these measures: joint treatment using hydrophilic material, then dam body grouting, upstream raking and pointing, and in 2 dams we carried out geomembrane works, Upper Bhavani and Cellular Dam. We can see that how significantly it reduced this intervention, reduced the seepage. In Malaprabha Dam, the initially observed seepage was 850 liters per minute, and after the intervention, we noticed that it went to 90 liters per minute. So it's a substantial reduction. So similar other examples like Kanirapuza Dam of Kerala, we can see 398 to 70 liters per minute. Almaty, Sarvalar Dam, geomembrane works was carried out. Structural safety, yes, it is important because in many cases we have seen that the slopes of the dam are damaged, or if there is any change in the seismic zone from seismic zone 2 to 3 or any revision, or if there is a change in hydrology, there is a change in MWL. So these put additional loads on the dam structure, and these are some kind of issues that I have flagged. And to counter this to counter this issue, dam upstream and downstream slope protection and drainage works were provided. Concrete backing was also provided in certain dams, and general repair of cracks and repair of abutments were done. This is a typical example. In Pichipare Dam, we implemented backing concrete to improve this stability concern. It was found unsafe under the seismic loading. Operational safety is also important. If you check the wear and tear of the this HM components, there is a deterioration, and we need to take. We took measures accordingly, like gates and hoist for the additional spillway, and replacement of gates and hoist. And these are the typical examples. Like Krishnagiri, major HM rehabilitation works were undertaken. In addition to the structural component, non-structural activities are also interventions are also important. Like we prepared emergency action plan, then operation and maintenance manuals. In emergency action plan, we carried out dam break analysis, then inundation mapping, then a population at risk, And then based on that and on those information, emergency action plan was prepared. And this basically, and these actually in DRIP, we are focusing on few dams. But for this, to carry out for 6,000 dams, we need a huge capacity building of our dam owners. Some of the best practices, which we already seen, underwater ROV repair and inspection was carried out. Then application of advanced technology in the repair materials for dam rehabilitation works. These are some of the examples. Application of geophysical investigation, geophysics and seepage analysis of the dams. Now coming to my conclusion and recommendation, which is the most important part. We should carry out risk-based prioritization for selection of the dams for the rehabilitation, and fund allocations should be to ensure safety of the vulnerable dams having greater hazard potential. And we should also not only focus our DRIP funds for routine maintenance purpose or regular rehabilitation works. These can be well carried out by state governments. We should seek important and challenging works and complex issues that needs to be resolved through such kind of funding. Innovations, no doubt, it needs to be motivated in the area of repair and rehabilitation, inspection, investigation. And project preparation should start from an early stage in order to identify suitable dams also, and also to firm up the scope of rehabilitation. And best practices should be shared within the conference and also should be hosted on the government website for better cross-learning and experience. Knowledge portal also needs to be created where different agencies can share their best practices. So thank you.
Thank you very much. Thank you very much, Engineer Sharan. I was looking at the slide on CPS control results, Kerala and Karnataka. And the difference, in one case you see from 980 it has come to 78, the other case 340 to 91. The CPS reduction, it has something to do with the typology of the dam, or why is that strong, that kind of variation?
It might be dependent on the various kinds of interventions, like raking. If raking pointing means raking and pointing is done, so how it reduces the seepage means, and then grouting also it reduces substantially. So we carry out in stages. So first we attempt raking and pointing, and then we carry out grouting. And if it is not being addressed, then we carry it out through geomembranes. So that is the main objective, or like this.
Thank you very much. Good presentation. And I don't know what the latest thinking is in involving communities in the catchment areas of the dams. Recently, I was in Indonesia, and under a World Bank program, I found when I visited the project where there was an upgradation of the dam safety, spillway was improved, the storage capacity was increased, and as part of that, the people living in the area, both downstream and upstream, kind of were involved in the management of the dam, including participatory forestry management, emergency evacuation plans, regular drills and meetings at the dam site. I think it will become pretty common. I'm sure it is also happening in India. It reminds me many European and American countries, America now, where adopt a highway. The communities are encouraged to adopt a public asset, and you become a real stakeholder in the process. So I guess given the size of the dam, it can't be just left to the government, state governments and central government and organizations to manage. I think local people will need to be more involved. We have one more presentation to go, and I'm conscious of the time. We started really late, so don't be unfair to this session which I'm chairing, okay? So you'll give me a bit more time. So we have the last session by Engineer Sunil Pillai from CWPRS. And today I was reminded that this institution is close to the place where I used to have my aloo paratha when I was studying in the IIT. And he's going to talk about seepage control measures using grouting of masonry gravity dams. Engineer Pillai, the floor is yours.
Thank you, sir. Good morning to the dignitaries on and off the dais. Well, CWPRS has been rendering guidance for the repair and rehabilitation of dams since last more than 6 decades. So I'll be sharing our experiences which we had at CWPRS with regard to the design of cementitious grout mix, and with reference to the case studies, I'll be just explaining how effective was this. So what is the difference between leakage and seepage? Most of you are aware that seepage is a function of the permeability, whereas leakage will be through the construction joints or maybe through the rubber seals of the gates. So that we call as leakage and seepage. Now, what are the causes of seepage in masonry dams? I'll just one could be the foundation deficiency. Of course, we can go for cut and grouting. Then the leaching, that is the cementitious material comes out into the drainage gallery and sometimes on the downstream phase. Then there could be structural damages, some construction effects. Then it could be due to some natural calamities of disasters like earthquake and floods. Then, as I told, the leakage to construction joints and improper maintenance. So that's why now drip is helping them. Now, the adverse effects of seepage, most of you are aware. Now, how do we detect the seepage in gravity dams? Well, these are the various studies that we carried out in CWPRS, and all these studies we have got under one roof in CWPRS. That is, we have got facilities to diagnose the damages in dams. We can identify the weak zones. We can determine the in situ density. We can determine the in situ strength, modulus, Poisson ratio. All these parameters can be determined, and then we can go in even for the strengthening by carrying out some FEM analysis. Even that facility is also available in CWPRS. So most of the studies related to dam safety and rehabilitation, CWPRS covers the entire thing. Now, what are the limits of seepage in masonry dams? Well, it is expressed in lugins. So we can say, as per IS 11216, it should be limited to 2.5 lugins at upstream surface and 5 lugins at downstream surface. This is for masonry dams. Now, coming to the repair and rehabilitation, we can say the distresses can be due to multiple reasons, for which possible cause of distress, that is, some diagnostic studies has to be carried out and the stress should be given on that. And based on the results of these diagnostic studies, we have to go in for the actual repair procedure. So these are some of the treatments of foundation, upstream phase, and the body wall treatment. Now, remedial measures. What are the remedial measures? So the major remedial measures is grouting. So for this, it is very much necessary to specify the grout mix. We have to design the grout mix. We have to select the ingredients of the grout mix most suitably. Usually we go for OPC 43 grade cement. Then we go for fly ash. It could be processed fly ash, then silica fume. And then we go for 3 to 4 type admixtures. The admixtures can be superpressurizers, water reducing agents, accelerators without chlorine. And then sometimes we go for the anti-washout agents so that the grout doesn't get washed out. So normally there is a general saying that the cementitious grout has got shrinkage properties. So this is what we can just see. This is a masonry block that we have constructed in our lab. It was constructed in a very distressed stage and at a very lean cement mortar, say 1:8, 1 part cement and 8 parts sand. And then we means whatever grout mix we designed for various projects, we just grouted it into this masonry. And after around 2 years, we just tried to dismantle this masonry, but it was very difficult. So, and you can see this masonry also shows that there is, if the cementitious grout mix is designed well, the occurrence of shrinkage is very minimum. So, as far as masonry dams are concerned, and our experience goes, cementitious grout mix is one of the best method to reduce seepage to masonry. Now, these are the other remedial measures: shortcutting, pointing, adding of a concrete septum, use of geomembrane, and repair of damages by a suitable repair material. That could be epoxy-based, polymer-based, epoxy concrete, many materials are available in market. Now, this is the first case study. This is the Domihira Dam. It is in the Palghar district of Maharashtra. It is actually a very small dam. You can just see the intensity of seepage. It is actually in the Jawar Taluk of Palghar district. You can see just after first impounding itself, heavy seepage is occurring to the spillway portion as well as the flange walls. So the project authorities approached us This was immediately after the success of Temgar Dam, which one I will be covering in a later slide. And you can see this is what we recommended, because upstream in the crust, we could not go for dam grouting from the dam top. So we just told them to drill inclined holes from the downstream. And in such a way, this is the grouting pattern and grouting methodology that we had given to the project authorities, and the grout mix was and the grouting was carried out. You can see the various stages whereby grouting was carried out. And in this season, in March, April, they had even gone for shortcutting of the upstream surface. So here the benefit which we had was the entire reservoir could be emptied, so that the entire upstream surface was exposed, and then finally they went for shortcutting. So during actual grouting also, we render guidance to the project authorities. We visit the project authorities. We check the quality of grout. So there are various tests to assess the a particular grout system. Of course, there is a separate lecture from CWPR, so I will not be covering on that. So you can see one is the flow cup method, wherein the spread of grout mix has to be assessed. We have to assess the strength of the grout mix, its settlement. So all these things we check even in our site also. So you can see the seepage reduction before treatment and after treatment. So I think the seepage reduction which the project authorities reported to was around 80% seepage was reduced. And now they are going for treatment of the flange wall as well. So in flange wall also, they will be going for grouting and shortcutting. So almost 90-95% seepage is likely to be reduced. And this is the second case study. This is the Damni Dam, because as we know, 42% of the dams are in Maharashtra, and most of them are masonry dams. So in major dams, some seepage issues are there, like I told, leaching, then sweating in the downstream phase. So here also a lot of leaching issues, sweating and seepage issues were observed. This was a dam constructed in 1990, and due to aging, this is in the form of heavy seepage and leaching of water have been observed. So here also, of course, we had recommended shortcutting and dam body grouting. Dam body grouting they did from dam top up to the inspection gallery, and that too they did it in two stages, the primary and secondary stage. And you can see the seepage has reduced from 197 liters per second to 41 liters per second. That is around 77% reduction. You can see before treatment, you can see the photo here, and after treatment. And the Badsa Dam. Badsa Dam is the major source of water for the Mumbai Municipal Corporation and Thane Municipal Corporation. So these are the salient features. Here also similar issues were there. And initially when we carried out the inspection 2017, lot of issues that has been solved. So you can see before and after. And finally coming to the final case study, this is the Temgar Dam. You can see the huge seepage through the dam body. And you can see we have designed a particular grout mix. You can see the grouting pattern mentioned. It was just like a patient in ICU. We had gone for injection from dam top to the gallery, upstream phase, downstream phase. Then the grouting was carried out. And this is before treatment, after treatment. There's a video you can just see. It is just a 1-minute video. In 2016, that was the seepage. And in 2019, the same monolith at the same water level. This is how the seepage reduction was achieved in Temgar Dam. It was a unified effort from CWPRS that we could do it. And of course, thanks to the project authorities, even the project authorities are also over here from the government of Maharashtra. And this is the media news. And now they call it as the Temgar pattern. So in most of the masonry dams, they are going for this pattern. And now coming on to concrete dams, because they say, this is a literature that I obtained from an international journal. The cementitious grouting is equally effective even in concrete dams if it is designed properly. And now coming on to the conclusions. So if you are going for proper diagnostic and investigative studies, and then we apply for the actual cementitious grouting, it is very effective to reduce seepage and thereby avoiding the loss of precious water. So thank you all for your patient hearing. Thank you very much.
No, thank you for your excellent presentation and the video. And a big thank you to everybody in the panel for excellent presentation. We're supposed to close at 11:10. The organizers were kind enough to give a few more minutes, so we'll take those 2 questions. How many people have questions? So I have a sense of time allocation. 1, 2, 3. That's too many. Green shirt. आप पहले आइए. माइक दीजिए वहां पे.
I am Jigar Jariwala from WRD Gujarat, and my question is to Dinosaur Concrete Solutions that if we have issues like downstream surface wetness or springs at downstream surface, so which treatment we should go first for dam body grouting? Either we should go first for upstream surface treatment. Is there any written regulations for that?
Note करके रखिए. We'll take all three questions and then you can answer. Okay. आप बैठ जाइए.
Okay.
Can we give the microphone to person at the end? Yellow shirt. Yeah, please.
Hello, sir. Good morning, sir. Myself, Hanmantappa, I am a scientist D from CWPRS. My question is to Sri Madhav, sir. Sir, you have mentioned that bond strength you achieved is 2 MPa. So, is there any studies this high bond strength is going to affect older bonds, which may have weakened, that there may be some pulling or like that criteria, whether this criteria is studied? And second question is whether pre-grouting and post-grouting of the dam water leakage, whether it's assessed.
Okay, 1, 2. There was one question here, I believe. Can we get a microphone here? This gentleman here. And you will ask the question, okay? Please go ahead.
I have to go straight. Thank you very much for the presentation. I have some 2 observations which I want to share with you. You have been speaking much on the seepage. Yes, it's good, but according to the dam safety perspective, I think the threatening phenomena should be piping, though you have already shown the picture on the concrete dam, I can accept that. But I think on the earth-fill dams, piping should be the phenomena to discuss on this conference and how to minimize that one. So that is, I think, is a threatening phenomenon. Another observation, very interesting, is you have spoken, the previous speaker, you have spoken much on the issue of the freeboard. And you found about 51% of your dams have lack of freeboard. So that's a good observation, but did not take much time to tell us why that freeboard has been equaled or exceeded at this moment. And what are the real solutions? Because putting a parapet wall today, it may be exceeded tomorrow. So what are the scientific justification for your solutions which you put forward? Thank you very much.
No, thank you. Great question. A question. This is the last question. A black jacket behind. Yes.
Hi, I'm John. I'm CEO and founder of iRov. We did the ROV inspection for KRS actually. So one of my input was, can we standardize the inspection techniques? Because what is the number of grid lines and for dam inspection, so that we get the standard outputs before the rehabilitation. So can we do a standardization of the proper inspection methodologies for dams before any repairs?
This is with regard to the first question you had asked, whether which we had to go for first, whether we had to go for the actual grouting work or the upstream surface treatment. So it is always better to go in for the grouting work, because what it actually improves the density of the dam. And suppose if there is some loss of grout, means it can come to the upstream surface, isn't it? So if you are just arresting the flow of the grout from the upstream surface, it may add up to the pore pressure to the dam body. So whatever treatment, first go in for grouting and then go in for the upstream surface treatment, whatever you prefer. It could be pointing, or it could be shotcreting, or it could be giving a membrane or some geotextile in. So that's the priority. That's what we are carried out for most of the dams. That's what CWPR's experience shows. It's not audible.
Sir, is there any written guidelines for this? Whatever you are saying, that first we should go for dam body grouting.
It is given in some ICOL publications as well.
ICOL publications. Yeah. Thank you, sir.
Okay.
One question she has already answered. The second question about post-grouting and pre-grouting. this one question he has asked. So normally we conduct, the grouting, the permeability test. After the grouting also we are conducting. So if satisfied the results, then we don't need to go for the other investigations. The second one, so we also conducted the tomography after the grouting, and we saw is there any the weak points are there in the along the dam. So that also we have confirmed. So after the grouting.
I have a quick question regarding the seepage, to understand what the effect of this seepage on the stability of the dam. Because the problem for the dam is not just the seepage itself, it's uplift pressure. And the question is, do you install piezometer to measure the pressure before and after the works? There is free presentation on seepage reduction, and to better understand if you take into consideration seepage from the stability point of view, it means that you have to take into consideration uplift pressure. It means, do you install piezometer to follow?
See, the uplift pressure normally, while the dam design, we know the uplift pressure. So after some time, so we measure the uplift pressure. If it is more than the design pressure, then I have to go for this, the cut and grouting. So reduce the uplift pressure, bring the value within the design value. This is what normally we follow in the drainage gallery.
I just respond to the one question about the freeboard, and I think as the climate change impact has intensified, we have seen many dams are facing such a problem, and so we recommend this providing this comprehensive approach, including this structural measures, including additional spillway capacity, and then also the changes of the reservoir operation rule and rule curve and so forth, and then also introduction of the flood forecasting system, and also pre-drawdown of the reservoir before the peak flood comes and so forth. I think we have had an excellent presentation and the question and answers. Enjoyed very much, and I think this is very useful for use to document these, so that will be disseminated into our client countries. Your experiences, practice really helped provided the good practices, information, and so forth. So with this, I really would like to thank you for all who made the presentation and participated in this session. Thank you.
I think we'll break for tea, no? Thank you.
Well, can we have a round of applause for everyone? We'll request, please, if you can just stay with us for a little bit. Before we formally end this session, we would like to present a memento to our speakers on the dais. Can I request Ms. Debashri Mukherjee, Special Secretary, Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India. Ma'am, if you may please present a memento to our chair and co-chair for the session. Can we have a round of applause for ma'am, please? Thank you very much, Mr. Sarojha, for being a great chair and for weaving the entire session together. Ma'am is coming from here, right in front. Let's give it up for Mr. Jha, please. Global Director at World Bank. Inviting our co-chair, Mr. Sataru Ueda, Dam Specialist Lead, World Bank. Thank you, sir, for your presentation and for overlooking the session. And thank you, ma'am. I will now request our chair and co-chair if they can kindly help us do the honors for the rest of the speakers, please. Sir, yes. Mr. Philip Vincent Lazaro, Senior Dam Specialist, World Bank. We would like to present a memento to you. I'll request a co-chair if he can also join in. Mr. Ueda, if you can please help us do the honors.
This is not fair.
Mr. Satari Ueda with us here on stage. Mr. Madhava. Engineer Satish Kumar Singh, ULVNL Limited. Engineer Saurabh Sharan, CWC. And of course, Mr. Sunil J. Pillai from CWPRS. And right after this, I request everyone on the dais if they can kindly join in front for a group photograph. I'll request all speakers to please be in front. Let's get a picture together and remember this session. And for everyone joining us here, we will be breaking for tea for 20 minutes. Just to request you and let you know, there are 2 places where tea is being served for everyone on this level. It's in the convention hall, which is outside. And for everyone on level 1, there's a multi-purpose ballroom or an area hall. This is what we call it. We request you to please join us for tea over there. Thank you. Once again, thank you to everyone on stage. Well, ladies and gentlemen, thank you very much for joining us back right after tea. We are all good to begin with our next session for the day. Requesting everyone who's here to come and are still outside the auditorium, if you can please join us back in and take your respective seats. Our next session for the day is about operation, maintenance, and emergency management. This session will be chaired by Dr. Rajan N., Chairman and Managing Director, KSEB. He's an IS officer, Kerala cadre, and now in the rank of Additional Chief Secretary. He's the Chairman and Managing Director of the Kerala State Electricity Board Limited. He's basically a doctor graduated from Nagpur Medical College. Under his guidance, the dam safety officials have not only been led but truly inspired to operate dams in the most scientific and meticulous manner. I will be requesting Dr. Rajan to please join us on stage amongst a round of applause from everyone in the room, please. Moving ahead, our co-chair for the session is Ms. Sumila Guliani from the World Bank. Dr. Guliani is the manager for the World Bank's water practice in South Asia, covering Bangladesh, Bhutan, and India. Prior to this, she served as program leader for sustainable development in India, and in this role, coordinated the bank's work in several practice areas, including water, environment, agriculture, and urban development. At its peak, the program comprised an investment portfolio of around $23 billion in 75 projects. Requesting Ms. Sumila to please be here with us. Joining us for the discussion or the presentations on stage will be Banzi, Principal Consultant, Banzi Consulting Services, formerly Head of Dam Safety and Engineering at Water NSW. Let's hear it for him. Mr. Tirumalashwara Reddy. He's here on behalf of DHI AS Denmark, and we will be requesting him for his presentation on stage. Mr. Narendra Kumar Goyal from IIT Roorkee. I just paused because I need to hear an applause. Thank you. Mr. Muthukumar Ramalingam from ICDS Technology Services Private Limited. Mr. Ankit Kumar from CWC and Mr. Sudhir Gupta from Hydro Design. Well, these are all our panelists here with us, and then I hand over the stage to the session chair to kindly take the proceedings forward. Dr. Rajan, if you may.
A very good morning to all of you, and thank you for your kind words of introduction. We have been, since yesterday, hearing excellent sessions, and also I think our Honorable Vice President has given us a message. And we have been also seeing and witnessing, and that is what we have also highlighted during G20, that look within and you will understand what are the solutions to the problem. So as I was introduced as being a medical doctor, in fact, what I am doing in dams and dam health. So whenever I hear the health, in fact, all my doctor in me, in fact, is woken up, and then, I take a look at certain things. So if we look at the topic of now discussion, operation, maintenance, and emergency management, we have been listening to all the experts who are gathered here on the dais and off the dais regarding what is the importance of dam, and then we have taken a look at how we are going to identify what are the things which are basically required to do dam management successfully. So then logically question comes that unless and until we go for the diagnostics, it is just not possible. So then the second logical question pops up in my mind is, what are the diagnostics that we need to do now? So there was a time when we used to do in a routine way, signs and symptoms, take a look at things and go for the interventions. But now with the advancement of technology, in fact, we are in a place that we have to go far off, in fact. At this point of time, for a human health, somebody sitting anywhere in the world, in fact, guides the doctor to do a robotic surgery. And perhaps, in fact, surgeries are also performed, not only telemedicine, but it is performed on a human being. If we can do that, then why not on the structures like a dam, which are fabulous structures? They have shown us for centuries that they withstood all the pressures. But at the same time, inanimate objects also required operation and maintenance so that they will always remain healthy. So with these few words, in fact, certain important thing which I will put across to all our distinguished panelists, that please keep up the time. That is what we have been following since morning, and that will really help all the esteemed speakers and also the audience to make use of our question and answer session. So I think we will have 10 minutes each, and I will sincerely request all of them to keep that time, and I will personally, in fact, manage that. I'll request my co-chair, in fact, she is expert in the sector, to then follow up with the discussions after the presentation and also Q&A session, and then later on we will go for sum up. So before we start, in fact, I have some key questions which I thought that I will share with our distinguished experts here and also among the audience. What are the advanced technologies that we can use to do the assessment of the dam safety plus health of the dam, and then based on that, what kind of operation and maintenance plan one should have? That is what we need to do. So there are two things. One is a reactive, and then there is a proactive. So whenever we see anything, in fact, we decide certain things and go for interventions. But I would emphasize on whether we are proactively looking at the things and taking certain measures, which will definitely help. Second important thing is our stakeholders, like all those who are at the helm of affairs, they will be taking care of it. But I feel the primary stakeholder are people. The community around the dams where we have built, and the community who is using all this infrastructure and its benefit, they need to be involved. So what are the ways by which we can take a look at their involvement in case of non-direct intervention to the dam system, but even outside the dam system, what are the interventions possible? That can be also one area. And third one is in fact my personal interest for all dams, because of the in fact monsoon first hits in Kerala in India, and therefore this is very interesting thing. After our experience of floods, in fact all the dams are having a rule curve, and we meticulously follow this rule curve for taking a call regarding the opening of the spillways, etc. I would urge the experts, if any one of them is going to do, whether we are having a AI/ML based modeling, because we are having excellent historical data, and whether this modeling can tell us that this is the time, or you can still wait for some more time and don't release the water, because ultimately that water gets converted into energy. So it has to be a win-win kind of a model, and whether there are these possibilities. That is my third question to the experts, perhaps in the gathering, or who are all sitting on the dais. They can throw some more light, which will be helpful for all the other managers. And my last point, when I met madam yesterday, she said that it is good to see some dam owners here, and it hit me. In fact, I am a humble government servant, and then she acknowledged and saying that a dam owner, and then I realized that yes, this is a privilege and excellent opportunity that one can very well say I am a dam owner, and that is indeed made me think that yes, here is the one more area where one can play a huge role and take things forward in our country. Thank you very much. Now I will request my co-chair to say a few words, and then we will go to that.
Good afternoon. Thank you, everybody, for being here. And it's a real privilege for me to be joining you for this conference and for this session. I'm personally very, very interested in the operations and maintenance story, because I think as a country, we have become excellent at constructing assets and at doing marvelous engineering to build things. And we have now a vehicle on the moon. There is no doubt about the engineering prowess of this country. But I think there is a challenge on asset management, asset maintenance, and utilizing the potential of the assets we create, because all of the celebrity seems to be around building new things and opening new things, and not enough celebration is around maintaining and managing these assets. So we heard yesterday and today how some of the dams are 2,000 years old, and the Krishna Raj Sagar Dam is 100 years old. I had the privilege of visiting Krishna Raj Sagar in June, and Mr. Madhavan is here. He showed us around. So how do we make sure that all our dams outlive their, go to 100 years and beyond? And how do we create a culture that we celebrate the success of operations and management, number one, and number two, that we put in the financing that is required to operate and maintain these assets well? A third issue that arises that has been mentioned, I think, yesterday by several people, is that we have very few in the world dam experts and engineers. And so you are a very important capacity for India and the country. And we have to grow that pool of talented people who will own and operate and manage dams, not just for India, but as my director Saroj Jha was saying, share that expertise with the country. And it has happened in other sectors. For example, the railways has a advisory and consulting arm that is extremely successful. So I don't see why we won't have a dam engineering and maintenance and management arm that is equally successful. So I don't want to take much time. I want to hear from all our experts, and it's a real privilege. Thank you for having me. So with that, let me hand it back to the chair.
So our first expert is from Mr. Sam Benzi, Principal Consultant, Benzi Consulting Service. He was formerly Head of Dam Safety and Engineering at Water in New South Wales. Over to you.
On everyone, and also Mr. Minister, thank you for joining us as well. I think I'm a bit honored to have the chair who is a medical person, because our industry, I think, can learn a lot from the medical industry, especially on the topic of what we're talking about today. But before we do that, I just wanted to reflect on a couple of important themes that have been coming through over the last day. So if we start from, the Vice President was talking yesterday about the need for us to be proactive, to be strategic in terms of how we manage our dams and our facilities. And if we go down to what the Minister said, he was reiterating the same message around operational maintenance. And I was talking to the Minister just then, some of the challenges, they're facing in terms of, how the dam system is actually working, managing the glacial inflows and understanding that. And then the director from the World Bank, was talking also about some really key themes around, are we taking dams to be static? Our thinking, is it static? Should we actually be thinking a bit more outside of the box and starting to think about, the global trends that are happening around us? So all these ideas, and I think opening remarks that we've just heard, I think are music to my ears in terms of, thinking about asset management, thinking about how we are, proactive in how we manage dams. So I'm going to try to cover some of those as I go through some of the experience we've had in New South Wales and Australia. So just by introduction, I've got about 30 years experience in the dams. I've spent the last 20 years leading the dam safety and engineering functions in some of Australia's largest organizations. So some of the learnings that I'll be sharing, I think, are coming out of that experience. So, for those who might not be familiar, I think some of this was shared yesterday in terms of just knowing where New South Wales is and in the Australian context. Introducing the topic, I think the importance of O&M cannot be understated. And I think the more we think about operation and maintenance, the more I think we need to rethink about how we define that. As an industry, I think for a long time, we've defined operational and maintenance in a very narrow sort of way where, it's all task-based, and this routine things we need to do. But if you think about from a life cycle of dams, the operational phase of the dam is the longest phase. And that's where we spend a lot of time, a lot of money, managing the dam. And if we don't do that well, obviously that increases our, costs. It brings forward some of the risks, and then we end up spending a lot of money. So I think maybe just redefining how we think about the operational phase of dams, and then how we think through how we plan and execute that, I think is quite important. So just to help with the presentation today, I thought if we, sort of use this Plan, Do, Check, Act, it can just help us to cast, our eyes on what we're doing and, identify the things we could do better, or, the things we reinforce what we're doing better already. So looking at the New South Wales context, the regulatory framework, which Chris presented yesterday, so I'm not going to spend time on this. Peter as well spoke to this. So New South Wales, we've got a very stringent regulatory framework, and that framework builds on the framework that was there before. But I think what's different with this one is about including ISO 55001 into the legislation. For me, that is a game changer because it changes the way we think about dams in the way that we actually manage dams. It brings a more holistic way of thinking about dams. So I'll focus a little bit on ISO 55001, and then we sort of can go deeper. So when the new regulatory framework came into being in 2019, all the dam owners were given 2 years to develop their plans to comply with that regulatory framework. I at that time was leading the engineering and dam section at Water New South Wales, and the first thing we had to do was to unpack what does this new regulation mean. What is this ISO 55000 all about? How do we demonstrate that we're actually achieving that? And then also, what can we learn from other industries? The aircraft industries, the railways, and some of those, the oil industries, they've done some fantastic work in terms of building, systems that are, more functional, more effective in terms of how they manage their assets. So what can we learn from that? So we spent a fair bit of time looking, unpacking, and learning from those experiences. And that helped us to then come up with a holistic plan. One of the things you immediately see when you start thinking about things from that ISO lens is dams are not just a special asset sitting on the sidelines. They are an important asset in the context of the business. They're there to help the business achieve its objectives. So, it's not all about compliance. I think we normally make that mistake where we, for years, we've always think about when we're preparing O&M plans, we're doing that whole stuff, we're thinking more from a compliance point of view, but we're not thinking about, what are the business drivers, what does the business want to achieve with these assets, and how can we align that compliance element with business requirements, but also if you're providing services, the decisions we're making about how we manage those assets also impacts on the dollars that go into investing in those dams. So by embracing this ISO 55000, I think it helped us a lot to rethink and reimagine and broaden our thinking around, what good practice looks like. Now, once we had the plan in place, the other point then becomes, you need people with the right capabilities, skills, and competencies to actually execute the plan. A plan is as good as the people who are, implementing the plan. So how do you make sure that, you've got the right capabilities? And I'm really pleased to hear, I think a lot of the work the World Bank is doing, with the Indian government in terms of raising and capabilities and centers of excellence and all those training programs. I think that's fantastic because in our experience, when we looked at it, we have a new regulatory framework. How do we comply with it? We started looking at the competencies required to deliver on all the core areas of your O&M in this case. And out of that, I think two key themes came out. One was we need to make sure that we've got people with the right skills to do most of those jobs, but at the same time, we need to have a competency framework that we can use to assess those skills, and we can develop people, to the level of maturity that we need. So that was important. One area that I think we normally don't talk about is we're focusing more on engineers and the most senior people, which is great. But also, I think the operational staff, they are the people on the front line. Those are the people who are eyes and ears on the dam. And if we don't make sure those people have got the right level of skills, then we might be brilliant in the background, but we are going to miss the opportunity to actually get the information we need in a timely manner. But also, if we train those people enough and we cross-skill them so that they actually are able to do various functions on the dam, it also cuts a lot of time and effort and money, because if you think about it, there isn't a lot of money out there to do a lot of this stuff. So how can we maximize, the resources we've got? And part of that is, that's cross-skilling. And only that I might not have time, but I was going to give an example of, what we've done in that space. And then finally, I think once we cross-skill, we need to start thinking more dam facilities as systems, not as components. Because, we normally talk about, the mechanical people think about the mechanical widgets, the electrical guys think about, electrical, but it's not about that. I think it's each of those components by itself is not going to deliver the outcome that we're seeking. And I think, a good example, I think in the medical field as well, if we think about, we've got nurses and, we've got lab people and all those people, have got some basic understanding of the subject domain such that they contribute effectively to and can guide you and direct you in terms of, where and whom you need to talk to. So systems thinking is one area, and Eric spoke about this yesterday and some of the experiences coming out of the Oroville incident as well. So I think that's definitely something to think about. Right. It's not working on me.
Mr. Sam, 2 minutes, please.
Oh, there we go. All right. So yeah, I'll quickly just go through. So I think the next bit is about, the processes you need to have. So if you don't standardize the work that you do, and you don't document the work that you do, and you don't integrate that work into the broader, systems within your organization, dams are going to continue to be on the sidelines, and you're not going to get the funding that you need. So it's going to be really important that you at least standardize the work you do so that it's consistent across the different dams that you're working at. There's less variability and maybe less risk there for risks coming out from operational space. Checking is also quite important. You can have a plan, you can have the people, but if you're not checking what you're doing, then how do you know that your equipment is going to work in anger when you need it to? So functional testing, really important. It's normally not done in some instances where you've got lower levels, people want to conserve water and all that. But how do you know that when you need to operate that gate, it's going to work in anger? Some people are scared, if we operate it, it doesn't close, what happens? Again, that's where I think controlled environments are important, managing those risks and then doing things in that way. Human errors, Eric touched on this yesterday, and I encourage those ones who have not read the Oroville report. Have a read. I think really good and really important. I think it gives some really good learnings about people are important, but we all also have got our limitations, and we put us under pressure. Our decision-making process can also be quite flawed, but how do we then design systems around that so that we're not exposing people to those risks? And then I think once we learn and we identify areas we need to improve, we need to then act on that. And part of that is having a learning mindset. A lot of organizations, I think we don't empower our people to speak up and to challenge and to also, help us to understand what's going on. I encourage, if we look at, I think, the generation of engineers coming through these days, we need to be empowering a lot of those people to actually have more say in, I think, how we think and manage a lot of these dams. So acting is all about reviewing, managing those things and improving. So in conclusion, look, I think this is a topic that is, from everyone, it seems from top to bottom, everyone agrees that things have to change. The world is changing around us. Climate change is happening around us, and technology is changing the way we think and act. We can't stay still and continue to do things the way we were doing them before. We have to think differently. And operational and maintenance is, I think, the place for us to think seriously about how we make those changes. Otherwise, we are going to be forced to make those changes, which is not maybe what we want to do. So thank you very much. I'll leave it at that.
Thank you, Mr. Sam. Now I request Tirumaleshwara Reddy to give his presentation on reservoir operational guidance based on optimization technique. He's a technical director in DHI India. And along with his team, I think yesterday we had Mr. Olaf Jensen and others. So over to you, Mr. Reddy.
Thank you, Chair. Good afternoon, everyone. First of all, I would like to thank the organizers for giving this opportunity to DHI to participate in this international conference and also presenting some of our technologies for the reservoir operations and also for the sedimentation studies. So my topic today is mainly on the integrated operation of reservoirs based on optimization techniques. That's where, Chair, you started some of these proactive techniques for any of these operations. So I think my presentation would cover some of those aspects here. So before I go into my technical presentation, I just wanted to give a brief about who we are. DHI is a Danish-based not-for-profit organization established in 1964. We are around 60 years old, having 1,000 employees worldwide. And we have been doing business in the 26 countries with the 26 offices, but we've been doing projects around 2,400 projects worldwide. We are into the world related to the water business, whether it is a fresh water or saline water. In India, we have started our operations since 2001. It's more than 20 years. We've been doing projects in different areas, mainly into the flood forecasting and early warning system. And we also doing projects into the integrated water resources management. And we also doing projects related to the sedimentation or morphological studies. This is mainly related to the rivers and reservoirs. Of course, we are also doing projects on the marine and coastal side, which I'm not going to talk in this presentation. Coming to this, the reservoir operations, as most of you know that the reservoirs are multi-purpose use. If you take every single reservoir, it will be used for agriculture or irrigation or even the usage of the domestic water usage or industrial water usage. We also use this water for flood control. Okay, and also it will be used for the hydropower generation. But how do you optimize these reservoirs for this multi-purpose usage? Okay, that itself is a challenging one or a complex. On top of that one, again, if you add multiple reservoirs, because it's not only the one reservoir, then you have got several reservoirs. And then several reservoirs for several purposes. How do you, optimize these reservoirs? That is adding again further complexity onto these operations. So that is where we've been using some of these traditional, the rule curve based approaches, where we have been, operating these reservoirs in a different ways. Short-term optimization or short-term operationalization, or even a seasonal operations, or even the long-term operation. So this is where I'm going to introduce, or I'm going to brief some of this optimization process. Again, this optimization process also started with some of these very linear approaches, or even some of them are non-linear approaches. And recently, or quite some time, there is some evolutionary algorithms have been developed. That is what the good approaches to optimize these reservoirs here. If I put these optimization techniques in briefly in three, as I said, one is a short-term optimization. This optimization will be mainly used during the flooding time, how the spilling occurs. You need to minimize the spilling so that there will not be a more flooding on the downstream of the reservoir or dam. So that is lasting for a couple of days to a maximum a week time. This is short-term optimization. And this is mainly to mitigate for the disaster management department how to mitigate this downstream flooding. The second one is a seasonal optimization. So mostly by end of the monsoon season, we need to make sure that when our reservoirs are having sufficient water, again, for whether it may be irrigation purpose or drinking purpose or hydro power generation purpose, we need to make sure that when the water is sufficient by end of the monsoon. That would be around 3 to 4 months time, which we put it as a seasonal optimization. Then the third one is a long-term optimization. Once the floods are over, once the reservoirs are full by end of the monsoon season, then how do you supply this water throughout the year for irrigation or even for the domestic or industrial usage or even for the hydropower generation? This comes under the long-term optimization, which is on an annual scale. What we generally doing with this rule curves is this is what the approach. We do some sort of hindcast approach depending on the data which is coming to the which is available in the historically, and based on data we also do some sort of the forecasting approach. That is what TOF stands for, the time of forecast, and then again the future forecast period. This is what is generally happening. But what is the second step? That's what I'm talking at the optimization. So after the time of forecast or the future forecast, this is where we will be using some of these objective functions or optimization techniques, to make sure that when there will not be a flooding on the downstream in the short term, there is a sufficient water during the seasonal operations, and at the same time there is throughout the year sufficient water for the long-term agricultural purpose. So that is what is happening here. But again, these optimization techniques also for the multi-purpose. So what they do is, they will be mostly complying with the existing rule curves by end of the monsoon or by end of the year, and also it will avoid the excessive the spilling from the dam, and it will also mitigate the downstream flooding. So these are the multi-purpose optimization techniques here. Of course, this is what the flowchart we've been using in these mathematical techniques, coupled and combined with some algorithms, evolutionary algorithms. So either you can follow the standard approach. Generally, we get the sum of the water levels as a forecast mode. Even the discharges also we get in the forecast mode. And then we use a standard approach that how to use these rule curve basis releases. But in the horizontal, if you see the optimized releases, that is where we use these algorithms to make sure that this is going through the certain process, the evolutionary algorithms or some objective functions, and finally make sure that so the water is releasing optimally. At the same time, we are mitigating the flooding. So this is a flow chart if you follow this optimization. If you do not follow the optimization, again, if you wanted to go the user-defined releases, you can bypass this entire optimization technique, go with our conventional way of storing the water or releasing the water. So this is the flow chart we use. But again, it also required some sort of data to do this optimization the process. What is required is you need to have a certain the forecast information. If you talk about this flood mitigation, so you need to have a minimum 3 days the forecast information. And it also need to have some hydrodynamic model, which mainly gives the water level variations in the river or in the reservoirs. And it will also give you the flow flow magnitudes, which is discharges. We also use some data assimilation techniques when the model is running. So even the data coming from the sensors will also be used into the model to adjust our modeling accuracy. That is where we use some of the data assimilation techniques. And then we use some sort of, again, the rule curves so that, by end of the day, so the water is not, kind of releasing too much, or at the same time, we are not storing too much considering the storage of the dam. So otherwise, this is the flow chart. This is where you see the AutoCal is our optimization tool within our Mike 21 suite of models. DHI has got this Mike software that will be used for any of these water-related modeling purpose. And this is a simple diagram. If you look at this red curve, that is what says that is a business as usual. That is a conventional way of doing this, the reservoir operations. And you can see the horizontal blue line. That is what the rule curve says. And what the green curves, which comes from this optimization technique, is that will make sure that the reservoir water is following this by end of the season or by end of the flood, the rule curve. So we'll make sure this water is not excessively releasing from the downstream of the reservoir. But this is again, this is for the short-term optimization, which is mainly for a week or 2 weeks time, and then the floods are happening. So with that, the optimization tool and also the process, we did some study for the Krishna Bhima basin in the Maharashtra. So this is one dam or reservoir, Ujjani. And if you see on the left-hand side, the top graph, which is mainly the water level in the reservoir, you can see the red one is the rule curve, and the blue line is optimized water level, which is not exceeding the red line. 2 minutes, yeah. So this is mainly for the short-term optimization for the water level and also the discharge. You can see the blue line in the below graph, which is not exceeding this rule curve-based discharges. So this short-term optimization will make sure that you will not have too much of water level in the reservoir. It's also not releasing too much of water on the downstream to mitigate the flooding. And then second thing is the seasonal optimization for the entire monsoon. There also you can see that the curves, the red curve is mainly using the optimization technique that you are not releasing too much of water on the downstream, so that that will make sure that you have a sufficient water in the reservoir to release the post-monsoon season. And you can also see the storage in terms of the million cubic meters, MCM, that they were rule curve-based approach and the optimization-based approach, both are having some correlation. So by end of the monsoon season, this will be tested for the Koina reservoir in the Maharashtra. And the third one is, which is a long-term optimization, mainly for the irrigation purpose. So there also you can see using this optimization techniques and also using the historical rule curve basis and having the different cropping optimization patterns. What if there is a dry year? What if there is a wet year? And what if it is an average year? That means there is not too much of flooding, at the same time not a drought season. So for that average year also, we can use these optimization techniques, make sure that for irrigation purpose you are having a sufficient water, so that you will not have any deficit for the agriculture purpose. So this is a long-term optimization for a year. And what if if you again in the Krishna Bhima basin there are too many reservoirs? If you put all the reservoirs together in an integrated manner, that's what the topic also, integrated reservoir operations using the optimization technique. So we combine all the reservoirs and we did it. Here also you can see for the dry year and then wet year, the water level in the reservoirs are optimum level using the rule-based curve and also the optimization techniques. And with all this integrated and multi-purpose and then multi-reservoirs, so if we use these optimization techniques, finally you will get to know that when in a river upstream to downstream, how the water will be released, the discharge with the different quantities. So that is what this combined optimization technique within this Mike tool we use for this Krishna Bhima basin. And just to summarize, I wanted to emphasize here that when there is optimization techniques which you could use for the short term or a seasonal or even for a long-term based reservoir operations to mitigate the floods, also to store enough water, and also to supply sufficient water for the irrigation purpose throughout the year. So the tools are available and tools have been tested thoroughly. That's all from my. Thank you so much.
Thank you, Mr. Reddy. Can we have questions for the first two speakers? I'll follow the sir's pattern so that we can break the monotony and we can have some interaction. question from my side. You have said that short-term seasonal and long-term optimization. And actually, after the forecast, what actually is happening based on that, if we do the data feeding, whether we will be able to tweak that what actually is going to happen and then again readjust what we are planning.
Well, whether it is a short term or a seasonal or long term, what we basically doing is we have the a forecasting model with us, okay, which is based on the discharge information in different locations. But while we are doing this forecasting exercise, we consider the data assimilation technique. That means you also get the data from the sensors. That sensor data will try to adjust this the forecast information, and that will give you more accurate information for the shorter or even also for the midterm.
Okay, you can speak. We are all silent, so I think one can hear you. Yeah.
Oh, they're bringing a mic. They're bringing.
I am NN Rai. I am Director Hydrology Central Water Commission. So I have very specific question. This is related to the Kerala reservoirs. In Kerala, after the year 2018 flood, most of the rule curves of the reservoirs have been revised, and it was based on our study in which we carried out a very detailed study of 2018 flood. But what we have found, in the case of Kerala, your time of consultation is hardly 1.5 to 2 hours. Okay, and for such steep terrain, your 1 hour rainfall, how much rainfall is taking place in 1 hour, that matters. 1 hour rainfall, say 40 millimeter rainfall has taken place. Your whole scenario is going to change. And so how your model is going to be used there. And number two, whatever you have seen, you are showing only one rule curve. No, there are 3 rule curves. Upper rule curve, conservation level rule curve, and lower. Always you make on Excel sheets beautifully, we can make 50 percentile flow, 75 percentile flow, and 90 percentile flow. Your reservoir has to be remain between these upper rule curve and lower rule curve, and between conservation rule curve and upper rule curve, there is always a flood cushion. Government of Kerala has taken a very good step. Now they are giving some additional 0.5 meter flood cushion below, just they are keeping the reservoir in the monsoon period 0.5 meter below FRL. So what is your view, whether can we do optimization for such type of cases or not?
It's a good question, sir. But if it is a very short duration, as you said, if there is a 1 hour rainfall and if it is having a 30 millimeter of flooding, I doubt that we cannot do it in such a short-term optimization. What I mentioned here is that short-term means at least that will be few days to at least a week duration. But I suspect that we can give it short duration.
Thank you very much for the presentation. I would like just to add on or to ask one very small question. You have already spelled out a lot of techniques, and you have short, you have season, and you have long-term kind of optimization. That's very good. But you have not spoken about the impact of the climate change, which I see. For instance, on the seasonal optimization, that's very important to think also on the climate. How do you factor out that one? Because we have changes. We change in seasonality as well. I think this is a problem also in India. We have the intensity and everything. So how do you capture this? I want to share to get your experience from that long presentation which you have already made. Thank you very much.
Once again, it is a very good question. Again, I have a limitation there because when I say this long term, this is an annual basis. So once the monsoon gets over, again by the next year monsoon within that 1 year, we are going to give this the optimization based water levels and then the discharges. But I'm sorry, this is the climate change based changes are not included in this 1 year and the optimization. But if we do it for the long term, probably we could use the climate change assessment.
I just want to come in on this point. As I mentioned, we were at Krishnaraj Sagar in June, and the realization was that the vast majority of our dams the capacity in most of these places is sufficient only for one season or one drought season. So if you have drought 1 year, somehow we could tide it out. But if you get a multi-year drought like in California, basically there is not enough capacity to help you ride out a multi-year drought, which is the kind of scenario that we expect to see under a climate change situation. So as several people have said before, yesterday and today, there is need to think about increasing storage capacity through better maintenance, maybe additional capacity and different kinds of storage in the country to help ride out multiple years of drought and intense floods. I think that storage capacity can help both of those. I just wanted to make that comment.
Thank you so much. We'll go to our next presenter, Professor Narendra Kumar Goel from IIT Roorkee. He will be presenting on performance evaluation of the operational inflow forecasting system for the Tehri Dam. Huh? He's there? No? He was. Over to you, Professor Goel. Thank you.
Yeah, good afternoon, everyone. Dignitaries on the dais and off the dais. Very good afternoon. And thanks to the organizers for giving me this opportunity to present our work on Tehri Dam. I'll be presenting the performance evaluation of inflow forecasting system for the Tehri Dam from 2018 to 2023. Friends, we have developed an indigenous flood forecasting model, rather inflow forecasting model for the Tehri Dam. We started working for developing this model in 2012, and for 4 years, like we took in calling the tenders, making the specifications, and then installing the instruments. And then, but since 2013, this system is working perfectly. So in general, inflow forecasting may be defined as estimation of future inflows to the dams, hydropower schemes, or any other location during monsoon and non-monsoon. Depending upon the lead time, the inflow forecast may be classified as intermediate term, short term, medium term, and long term. Why do we need the forecasting system for the dams and hydropower schemes? To get real-time hydrometeorological information about the catchment, to regulate the release of water through spillways, and to generate optimum electricity. Yeah, this is the Tehri Dam, which is the 4th highest earth and rockfill dam in the world. Tehri Dam is constructed on the confluence of Bhagirathi and Bhilangna river. And in the downstream, we are having the Koteshwar Dam. This is a storage dam with 2400 megawatt power generation, located on the confluence of Bhagirathi and Bhilangna, this 4th highest. Dam base width is 1128 meter. This is more than 1 kilometer base width. Dam top width is 25 meters. Design flood is 15,540 cumex with a gross storage of 3,540 MCM and live storage of 2,615 MCM. Catchment area is 7287 snowbound is 2424 square kilometer, rainfed is 4863 square kilometer. So roughly 1/3 is snow-fed, 2/3 is rain-fed, and in this catchment also 2/3 area is contributed by Bhagirathi and 1/3 area is contributed by Bilang. Maximum flood level is 835 meters, FRL is 830 meters, and minimum drawdown level is 740 meters. So in general, for any operational inflow forecasting system, these are the 6 steps. The system conceptualization is very, very important step and the first step in developing any flood forecasting or inflow forecasting system. Observation of hydrometeorological data, transmission of data, processing of data at earth station, forecast formulation and verification, and dissemination of forecast. Yeah, this is the first chart. Like this is the catchment map. Even this catchment map was used when this Tihri Dam was designed. So this map was obtained from the irrigation department. And prior to the construction also, some network was developed or planned for this Tihri Dam. When we started working on this dam, the first thing we did was the system conceptualization. That is, the line diagram for this entire catchment was prepared. And then we tried to map like which tributary is joining from which side and how much area that tributary will be having. So Tihri Dam is a typical dam where at FRL, the length of the dam is 55 kilometers. And in the dam itself, there are 17 tributaries which are joining. So here the system conceptualization was very, very important because it is having the impact on the type of model which can be developed for this catchment. So we decided, the network was decided like in 2013 when we were doing, then we went cautiously that, okay, like here the issue was that for how many stations we have in this catchment. So by this WMO guidelines and other guidelines, we decided the 12 locations, and also we kept in mind the how many tributaries are there. And then the sensors were decided, like at each automatic weather station, how many sensors we will have, what will be the mode of transmission, what sort of method we apply for the discharge measurement, because these are the hilly streams and where discharge measurement is a big problem. So then this is the location map, and this location map shows various hydrometeorological and GND sites in the basin. Now, the forecasting model is the heart of any forecasting system. Here, we developed, like we conceptualized this, like the forecast model, which we have developed for this. This is a combination of GIUH-based deterministic model for the intermediate catchment, which are directly contributing to the reservoirs, which are 17 in number. And we developed the stochastic models of RMAX type for the 3 stations, namely Maneri Bali 2, Ghansali, and Sarasgaon. Then this is a non-conventional model, but we knew that the reservoir length is 55 kilometers. There is a huge storage available. And so we tried some sort of additive model so that like if one segment is giving error, then the other segment is able to compensate that. Inflow forecasting up to the reservoir, lead times are 6 hours and 24 hours. Then we also use in this 1 day, 2 day, and 3 day rainfall forecast by National Center for Range Weather Forecasting for 0.25 to 0.25 degree graded rainfall, and 1 day to 7 day rainfall forecast for Bhagirathi Basin using WRF, GFS, and MME models. Like the model, we developed these 2 websites. Normally, out of these 2, one will work. Like for example, today, this the HTTP 43.227.134.91. This site is working, and these are the 2018-19 we issued 182 forecast, 2019-20 65 forecast, and 2023-24 the current monsoon we issued the 84 forecast so far. Like this is the plot of observed and forecasted inflows where lead time is 24 hours, and from November 2018 to November 17, 2000. No, this is 2020, and then up till 23 also, this is there, 2022, 2022. Then we try to calculate the performance of the model. So though on daily basis also we are forecasting, we are computing these errors. And normally, most of the days we are able to forecast having a forecast error of only 5 centimeter or up to max 10 centimeter. So the operational...
Excuse me, sir. In fact, one of the audience, in fact, their phone is on, and I think we can also hear some songs, so somebody, in fact, if it is backside, my request is, please keep off your mobile, please. Thank you.
So this last slide, the operational inflow forecasting system for Tihri Dam is working satisfactorily since November 2018. The mathematical model has been indigenously developed. The entire forecasting system has been indigenously conceived, designed, executed, and operated. The model results can be verified in real time and hence make it the system with verifiable results in real time. So for the dams, this is the main thing. Like there are many models for many basins, many dams. These models are there. They claim also that, okay, their performance is so good, but when it comes to the verification that, okay, like this is the level, like I forecasted this level, verify it, or what is the level, current level, let us verify it. So there the verifiability aspect, very few models are having this verifiability aspect. So similar type indigenous models are recommended to be developed for the other dams and hydropower schemes also. Now, having the experience of this developing this real-time operational inflow forecasting system for Tihri Dam, and also my background in forecasting, I did my master's from IIT Delhi in 1980, and the topic was the real-time inflow forecasting there also. So this International Center of Excellence for Dams will be happy to help the dam owners to develop their own operational forecasting models, and in the longer run, it will be far cheaper than the commercially available models. So this is my feeling, and that the dam owners, the hydropower scheme owners, they should try to develop their own models for forecasting, and this can very well be done. It's not difficult. We have done it for Tihri. We will be able to do it for the other dams also. How we did for Tihri? For Tihri Dam, like their engineers, they first did their masters And then one student, one officer of Tehri Dam, he registered for PhD, and during his PhD, the major work was done. So now THDC is having a complete control over the system. Also, we are having the complete control over the system. And thank you very much. I just want to tell this.
Thank you, Professor. Now we will go to our next speaker.
Okay, please.
Yeah, I will, because there are 3 more presentation pending.
Okay,
And they
thank
are
you
very
very much.
exciting presentation.
Thank you, everyone.
I would request organizer, one more chair, can be, so that professor can also sit along with us. Professor, you can also sit with us. So I am requesting organizer. Yeah. Okay, thank you. So I will now request Mr. Muthukumar Ramalingam. He is going to speak about bridging the emergency management domain experts' knowledge with the emerging AI and OT, and that is what I was requesting. So over to you, Mr. Ramalingam.
Thank you, everybody, and good afternoon to all. Thanks to nature. I have only 3-4 slides. You can next slide, please. So, okay. So since we are proposing the model like for the real-time monitoring, it is like a comprehensive real-time monitoring. Okay, so like if you have a geotechnical equipments, which is already in India, we have 2 scenarios. One is fully instrumented dams, large dams. Next one is even you don't have a light also. Like, sorry for that actually, because I have visited at least 5% of Indian dams, like 300 dams I have visited all over India. Some dams we are well #1 instrumentation, like our Idiki Dam. So we are fully instrumented actually. Some of the dams, even for visiting gallery itself, we have issues. So if you want to go with the integrated approach, so we cannot go with only inflow and outflow forecasting and with respect to weather models. We have to consider for all the aspects, like I have pointed for some of the major areas like hydrology, meteorology, geotechnical, seismic and geodic, along with the satellite imagery processing, which is going to be input for your model only. Okay, so based on that, we have now we are including for the expertise knowledge. This is one thing is missing for our prediction model. For example, if you access any of the sea level of the dam, they know about the dam from each and every corner of the issues actually. Once he is retiring, so how much the subordinate or the person who is going to get the knowledge from the sea level or the SC level, it is going to be a gap only. So we should have a prediction model where we can give the manual input from the experienced persons, like expertise. So input from the real-time sensors, from the satellite imagery, as well as from the expertise knowledge, which is missing now for the prediction model. We have so many stories about that. Even if you ask, because in our sector, the transfer from because in the ground level, reality I'm saying actually, all the dams are like 50 years old, 100 years old, 1000 years old. How much knowledge we are transferring to others actually? Some of the dams, even I don't want to name the dams. When we are going for the inspection, if we are asking for what is the purpose of this gate, then they have to call for 6 to 7 persons. So know about the purpose of the dam, the purpose of the gate at least. Some portion of the dam actually. Now when we are starting the session, chair expressed about the VR advantage. The doctor is sitting in Australia and he is doing the surgery in Chennai through VR, and we are landing the spacecraft in moon with AI. But where for the dams, which is closely related with our society, still we are lagging behind for the AI with the technology actually. My request to the audience, how quick we are going to adopt the VR and AI based model is the key for our to protect our society. If you consider our climate changes, we cannot say that I am going to be implementing my sensor for real-time monitoring. I'm going to be before that I surprised that the professor is done the PhD in 1980 for real-time monitoring. So I cannot say that next year I'm going to go for a real-time monitoring for my dam. With the current scenario, we have to go ahead of that. We have to adopt the new technology actually. Next, the proposed, which one already we are having installed actually, we are demonstrating the VR technology where you can digitize all the assets. For example, if we have 5,000 plus dams, we should have digital assets in our hand actually. For example, why medical field is this much ahead? They know everything in our human body actually. But how much we know, so I am not asking me actually. So many experts are there and they know very good actually. If they are retiring or transferring. For example, one AE may be there for even 10 years also on dam actually. He know each and everything for the dam. If he know in his mind that if I am opening this much height of the dam, then discharge may be this much. So if it is more than that, that village will be flooded. Maybe we are having documented. It is well documented. Flood management is well documented. But where is our time? Or if you are transferring the job to other AE or other in charge of the dam, whether they are referring it or how much knowledge we transferred about the dam from construction to here actually. How much we are digitally we are recorded. See, now we are having very easy and cheap technology where you can easily digitize your assets. For example, if you are carrying one VR kit with you, you can monitor even 5,000 dams at one time. If somebody is calling you, if you are a authority, I am calling from Kerala, then which dam? Then you can go to the dam. Then it is Idiki. Then yes, I am inside. Then you can say that, sir, you can see it through the camera. That now it is having this type of thing. If you are expert, then you can use the expert. No need to go to the field itself. So how quick we are going to adapt the new technology like VR. So you can feel free. You can come to our stall. We are digitized one dam. It is a matter of one day only actually. It is a matter of one day for digitizing one dam. So that much easy technology is available. First, the baseline for AI ML is secondary. First, in our all the Indian, India, all over world, even I asked for the Australia and Denmark delegates also. Still, VR is not introduced for the at least dam monitoring and operation. This is the best time for India. We have to adopt the technology for VR. The decision maker can sit their seat and they can take the decision. And for example, if you have a 20 gates. If somebody is reporting 21st gate is having problem, you can wear the glass. You can say that yes, as per the incident 20 years before, this gate was open to this much height. That time the village was reported flooded. Actually, flood was reported. That history, if you are wearing and if you are seeing the gate, you can able to get the full history of that gate. Otherwise, some portion of the dam which is not explained from the transferred AE or transferred site in charge. If it is digitalized properly, then he can make the same scenario, what was happened 2 years before in the same level of the dam level. Then the same solution will be applied. It is not going to be trial and error method again. So how much we are going to transfer the knowledge to the digital world, it is going to be a key point for to protect our society. It is a very cheap cost actually compared with other. So these are so again also we cannot adopt any single software for example, I have purchased Microsoft Word. You cannot purchase the same. I am from the X dam. Okay, you purchase the software, you can give to me also. You cannot adopt a single model or some X software for all the dams. You should have a tailor-made AI models that needs to be adapted for each, because it is going to be inflow is something different, catchment is something different, and siltation is something different for your dam. For the flooding is something different. So we should have a micro level AI models for each dams. It should not be software specific. Say this software is developed by X company or X country. This is very good model for our dam. You cannot predict that actually. We should have a micro level and tailor-made solution for each dam. This next level I am telling you, after creating the baseline. So what I'm trying to say that it is not going to be like from the sensing or transforming the. So we are having multiple options for transferring data also. Like now we are having IoT based satellite communication. VSAT is there.
2 minutes.
So how quick we are going to adapt and from sensing to N-mile connect. This is going to be key for that. If you are selecting the, so not only flood actually, if any something man-made disaster suddenly happen. So flood model we have. So the solution which you are going to adapt, it should have all the hazards related to your dam. So we cannot claim that it's not a flood. Flood model we have are, so yeah, definitely you are having all the records, but something happens suddenly means the AE or operator said new means you should have some already this one feeded informations. You should have multi-hazard management systems, not only for flood. So some of the early warning system I have shown. Thank you.
Thank you, Muthukumar. Now I'll request next speaker, who is from CWC, Mr. Ankit Kumar, to do his presentation on importance of glacial lake outburst flood study, especially in changing climate conditions. Over to you, Mr. Ankit.
Good afternoon, everyone. My topic on presentation on importance of glacial lake outburst flood, also called as GLOVE study, especially in changing climate condition, a case study in Chenab Basin. In this presentation, I will discuss about the alarming trend of increase in GLOVE peak as a result of expansion of glacial lake in Chenab Basin. I will also cover the causes, consequences, potential strategic measure that is associated with this growing concern. Let's take a look at the topic I will cover in the coming slides. First, I will discuss about the glacial lakes and climate change in Himalayan region. Then I will narrow our focus to Chenab Basin, region lies in Himalayan region. And then a GLOVE dam break modeling for calculating the flood hydrograph graph due to glacial lake outburst flood, and the specific input data and breach parameter required for the creating the accurate glacial lake outburst flood modeling. And then case study of GLOVE in Chenab Basin considering the 2009 year data and 2022. These study are based on the satellite imagery of 2009 and 2022, and result and discussion and followed by the conclusion. So glacial lakes are the natural part of the landscape, and their rapid expansion and has increased and increase, and they can lead to the glacial lake outburst flood. And Himalayan region are abundant with the glacier, and the snow covered with the polar region is facing the heat of climate change due to global warming. New lakes are forming and also resulting in the expansion of glacial lakes. As you can see in the figure also, that this is the figure one is the Gangotri Glacial Lake in Uttarakhand, Himalaya. It has retreated to 1700 meter from 1935 to 1922, and the study has found that the rate of retreat it increased from 20 meter per year to 38 meter per year, and the basin that are affected in India due to glacial lake outburst flood are Indus, Ganga, and Brahmaputra. In CWC, we are monitoring around 477 glacial lakes having area of more than 50 hectare since 2011, and around 385 glacial lakes of area more than 10 hectare since 2022. Now we shift our attention to Chenab Basin. this Chenab basin is the fifth largest sub-basin of Indus Basin, and covering total area of 29257 square kilometer, and that is 8.5% of the total basin area. And these two figure are the catchment area of Chenab Basin, and their location in the map of India. In Chenab Basin, glacial lakes are divided into four major types. First one is the moraine dam lake. These lakes are fed by the glaciers and dammed by the moraines. And second type is the ice dam lake. These lakes are on the surface of glacier and lake dammed by the glacier ice with no lateral moraines. And third type is the glacier erosion lake. These lakes form in the glacier through a result of glacier erosion process. And the fourth type is the other glacier lakes. These lakes are formed in the glaciated valley and fed by the glacier melt. But damming material is not directly part of the glacier process. Out of these four glacier lakes, moraine dam glacier lakes are more vulnerable of glacier lake outburst flood. These are the statistics of Glacial Lake in Chenab Basin. As you can see, there are, as per the Glacial Lake Atlas of Indus Basin, there are 397 glacial lakes have been mapped, covering a total area of 896 hectares. That is around 0.03% of the total area of the sub-basin. Around 367 glaciers have, that is 92.44% lake area, with less than 5 hectare lake area, contributing to the 40.48 of total area. And the remaining lakes with greater than 5 hectares in size are only 30, that is 7.56%, contributing to the 59.52% of total lake area in the sub-basin. And you can see in the pie graph also that around 61.21% glacial lakes are lying in the area lying in the region elevation along in 4,000 to 5,000 meter. And there is a type by distribution of glacial lake also. You can see here the 40% glacial lakes in Chenab Basin are the moraine dam lakes, which are more available for globe. Out of 397 glacial lakes, we have find out 3 glacial lakes are the more vulnerable glacial lakes based on their elevation, size, and location from the project site. In this table, you can see the a change in glacial lake area from the 2009 to 2022. You can see there are over the subsequent year, you can see the glacial lake GL1, GL2, and GL3 has increased from 62, 46, 45 hectare to around 110, 170, and 52 hectare. And the after critical analysis, it is found that the glacial lake 2 is more critical for the Chenab Basin. So we have carried out the study of globe for GL2, and we have estimated the volume of Glacier Lake 2 around 1.43 MCM based on the 2009 imagery, and 73.15 MCM based on the 2022 year imagery. Below is the graph of development trend of Glacier Lake. These are the satellite imagery of Glacier Lake 2, has taken in 2014 and 2022. Below images are Sentinel-1A, and these figure A and B are the Google Earth images. You can see there are remarkable increase in Glacier Lake area. Basic low is the sudden and often catastrophic event that occur when water stored in glacier lake is released rapidly. And the present study we have basically globe modeling is a type of dam break unnecessary flow modeling. And the failure mechanism associated with the moraine dam lakes are almost the same as of earthen dam, with the difference being only in the time of full bridge development. As in case of moraine dam, it is more porous and less inherent strength. That's why that's why it has a breach formation time lesser as compared to earthen dam. And further, the group modeling is carried out following using these two steps. First, we estimate the outburst flood hydrograph just downstream of the glacier lake, and then hydrodynamic channel routing of outburst flood to get the globe output at project site through proper attenuation and transition. In this case, we have distributed 1 in 100 year rainfall in the reach based on their catchment area proportion. So input data and breach parameter are important in any globe study. However, it is very difficult to predict the breach parameter. There are some guidelines and empirical equation available to estimate the depth and the volume of the glacier lake. As per the ICI-MOD guideline, Cirque Lake having the depth of Cirque Lake is 10 meter, lateral moraine lake is 20 meter, and moraine lake is 30 meter. Blocking and glacier erosion lake is 40 meter. And for calculating the volume, we are using the Christian-Hagel equation. And these are the equation for calculating the depth and the volume. And for calculation the width of the breach, we use the equation, Forlik equation, Von Thun equation, and the FERC equation 1987. These equations are also used for the breach parameter calculation of the earthen dam. These are the basic flow diagram for globe study based on the topographic maps, literature, satellite imagery. We first prepare the inventory of glacier lakes, then identify the possible vulnerable lakes based on the physical feature of the glacier lakes, and then critically analyze the glacier lake to map out the most vulnerable lakes, and then prepare the model and calibrate the model and disseminate the results. So present study is a globe study in Chenab Basin, considering the satellite imagery of 2009 and 2022, and the model is developed in Mike 11, developed by DHI in order to simulate the globe hydrography in downstream. And this study covered the major projects such as Tandi, Rasil, Bardang, Deoli, Dugli, Purthi, Sachkhas, Dugar, Kirthai in Chenab Basin. And the cross-section for 1D modeling is extracted from the SRTM 30-meter DM, and the roughness coefficient is calculated, estimated using the land use land cover data. These are the flood hydrograph or globe hydrograph just downstream of the glacier lake. As you can see, peak discharge as for case 1 is 2354, which is attenuated to 916 at 275 km downstream, and the flood arrival time at 275 km downstream is 9 hours. And if we carry the study for using the satellite imagery of 2022, it comes out that the at just downstream of the glacier lake is 12197, and at 275 km downstream is 3075, and you can see the breach top width and average depth is calculated using the empirical equation, and the breach formation time and size slope has considered same for both the cases. These are the results from our study. The roads represent the project downstream of the glacier lakes, and the column represent the distance of lake from distance from the lake, and the discharge, increase in water depth, velocity, and flood travel time for both the cases, case 1 and case 2. As you can see in the table, for Tandi HE project, which is located 98 km downstream of the glacier lake, the discharge, the globe peak is 1251, which has increased to 4459 at present in 2022, and the increase in globe peak is 3208. And for the Dulhasti project, which is located 264 km downstream, 264 km downstream of the glacier lake, here the globe peak is 925, and which has increased to 3121, and the increase in globe peak is 2196 cubic. Now I wrap up my presentation with the following conclusion. The very first step is in minimizing the threat can be start the monitoring of vulnerable lakes more actively and regularly. The next step would be carry out the desired study, model simulation of potential vulnerable lakes, and to share the outcome with the concerned stakeholder. It is also important to closely access the bathymetry changes of identified lakes instead of relying on the satellite and remote sensing data. And the various methods and techniques may be used to mitigate potential globe hazards in Chenab Basin. If environment permits, we lower the water level is usually lowering the water level is usually considered as the most effective mitigation measures. When the lake water level is reduced, the hydrostatic pressure exerted by the water on the moraine wall is correspondingly reduced, ultimately diminishing the risk of outbursts from the lake. And additional flood cushion may be provided during construction is this stage of the project to accommodate the increased discharge due to the increase in size of the glacier lake. Early warning system may be installed at the glacier lake and a downstream of the river reach that receive signal from sensor and transmit to the other remote warning station. We have to keep in mind that climate change is significantly impacting the Himalayan region, leading to the formation and the changes in the glacier lakes. Their rapid expansion and potential for glow pose significant challenges to the project downstream. Thank you.
Thank you, Ankit. Now, this is the last presentation. I'll request Mr. Sudhir Gupta to tell us about dredging system for reservoir. Over to you, Mr. Sudhir.
Good afternoon, everyone. And I am here. Will not take much of time. So try to be brief. So the topic that I am going to talk about is the dredging system for the reservoirs. Now, why do you require dredging is because the capacity of the reservoir may be going down. And it goes down over a period of time. And these dredging systems should be able to work without electricity, actually. So this is the scheme. There is a floating barge which carries a suction head down to the level of the sediments in the reservoir. Now the depth can be anything. So that means the system is independent of the depth of the reservoir. And the suction head can carry some kind of water injection system to break the sediments which are solidified at the bottom. And this suction head is connected with one floating inlet pipe, I can say. And this inlet pipe, floating inlet pipe, can go over the top of the dam, can also be connected to the bottom of the dam. There are two options to take the water out. If it is going over the top of the dam, then you require some kind of a water filling mechanism to establish the siphon. And that's how it works. Yeah. And it is successfully applied in one project in India, is in Malana project. This has an advantage to the client because you require very less water to exit the sediments, and it can run 24 hours without requiring any electricity. This is one video I would like to play. Could you play the video, please? So it is just a floating barge. On the floating barge, you have the suction head, which is going down using a tripod and a hanging mechanism. It goes to the bottom of the reservoir, sucks the sediments into the piping system, and piping system is completely free. That means there is no pump involved here, so you can suck any kind of sediments, including the stones. And there is no need for any maintenance requirements in this, and it works 24/7. So you can see that sedimented water coming out, and it continues. We have another sediment removal systems for the descenders. In this, the slotted pipes are laid inside the descender along the length of the descender. So these are multiple units, and this is modular, so it can be any length of the descender. Sediments are settled on the top of the slotted pipes, and they are connected through a junction box to an outlet pipe. And as soon as the outlet pipe valves are opened, it removes the sediments through the slotted pipe, goes into the box, comes out through the outlet pipe. Can we run this video, please? So this is a model just to show how sediments are removed. You can see that this model has a lot of sediments in the descender model. And you can see that as soon as we open the outlet valves, you see the sedimented water starts to come out. And we can actually collect these sediments if we want to. Otherwise, we can let it go into the river. You can see that these pipes are now visible, so the sediments are getting removed. And even the slots have started to be visible. And you can see that the sediments are going through the slots into the pipes. And you can see the quantum of sediments that are getting collected. And this is working without any electricity. And these valves are closed as soon as the clean water starts coming. So that means you save so much water. Otherwise, you just allow the sediments to go through in the bottom flushing system. So you save water, enhance electricity production. So we have a case study from Nepal, a project 7.5 megawatt, built in 2002 or something, 14 cumex of discharge. And it has so much sediments in the river that the plant has to stop for many days, and they clean up the descender and then start again. So we put this system there and it worked. You see, this was the condition of the system in 2013. You can see so many sediments, people going into the descender, removing it manually. Then we provided this piping system in the descender. You can see that there are 2 outlet pipes, 2 inlet pipes for each unit, and then they are laid slots facing downward. We can run the video, please. You can see that the sedimented water coming out of these 2 outlet pipes. And one outlet pipe is capable of carrying 900 tons per hour, the sediments. These have been tested and they have been proven. So the plant has become very successful and they were able to recover their cost in less than 2 years' time. Thank you so much.
Thank you, Mr. Vivek. Sudhir Gupta. Yeah. Any questions from anybody? Yeah.
Myself, Srinivas from National Water Academy. I would like to have 2 specific questions on AI-based approach and dam operations. I think it is evident that for a successful running of any machine learning or AI-based model, data is engine oil. And that AI-based model is considered accurate if it works well for extreme events. But here the question is, the data on extreme events is really questionable. So with the limited data of extreme events, the accurate prediction of floods, are using that models for dam operations, I believe it is really, doubtful. The another one is cyber attacks. For accurate prediction, your AI models should be open to real-time data acquisition. Like it needs to open, it needs to even dynamically predict catch the data of weather models and all. So in that case, there are chances of, cyber attacks on, those models. In that, the dam control operations may be, compromised. So these are my 2 specific questions. I believe some officer has given a presentation on AI-based approach for, dam control operations. I would like to hear from you.
Yeah, it is a very good question actually. It is a very big task only. For example, now itself we have to start to record all the major events in digitally to make the AI model perfect actually. Otherwise, even if you are waiting for another 50 years also, we cannot introduce AI with the dam predictions. Now this is the better time that even, for example, if Idiki Dam, now they have all the baseline data. If they are going for the next level, now only they have to go, like a Tigri Dam, like already they are having enough data. Now they have to start to train the AI models with the ML input. Then only we can able to get at least within 3-4 years or 5 years. If you are, then we can at least start to use. My proposal is like, if any event is there, you should have a 3 results in your front actually. One is AI prediction, maybe 30-40%. Next is real-time prediction, which is around 80, and another one is from the manual input, which is gathered from the retired officials. With these 3 only we can able to manage, but somewhere we got to start the system. So that is this one. And yes, cyber the security and this one is there, because we are going to access the open cloud. That needs to be developed. That security needs to be developed actually. Still it is a very good question actually. It is still open only. Thank you.
Thank you. Yeah, here is so please.
Myself, Dr. Alok Kumar, Water Resources Department, Government of Jharkhand. My question is with the dredging of reservoir. Actually, as far as this dredging is concerned, in the state, these sediments are mostly toxic. So my question is, how do you manage to dispose these sediments? How will we manage these sediments to dispose in a safety manner? And what remedial measures we can adopt?
Yeah, if these sediments are toxic, then we have to separate them and then dispose as per the safety requirements. So in our system, there is a possibility to collect the sediments through collection boxes or through collection bags. So that option is there if the sediments are toxic. Otherwise, if it is a part of the ravine system, the river system, then it can go through the river system and it will ultimately meet the sea. But we don't know how the toxics are coming into the river. And if it is stopped at the source itself, then the problem is resolved.
So are you going to do some tests before disposing into the downstream or any other river?
Usually not, because they were collected as a part of the river system and they were discharged into the river system. So it is ecologically not making any difference. It came into the system because we have built a reservoir to collect it. Otherwise, it was a part of the river system.
Okay, sir.
Still, as an abundant precaution, I think one can take a look at the testing of the sediments and see that it is not having any adverse impact on the environment and the system. That can be thought through. But what I have found is, through that presentation, in fact, Mr. Sudhir Gupta's presentation and some of the videos, even though this system is very well working, in fact, in India, there is only one working model. Why it is so that, other dams, in fact, now have not adopted, in fact. So we would like to more that perhaps I think, during the lunch, some of us will interact with you. Otherwise, we are eating away the lunch time of all our audience. So, we will close the interaction session also here. And I'll request, co-chair Ms. Sumila to, say a few words regarding wrapping up the session, and then we will go for the lunch. So over to you. Thank you.
Hello.
Thank you very much. So thanks to all the panelists for excellent presentations. I noticed that the bias was more towards the operation part of the O&M. So Mr. Reddy presented modeling that can be used for reservoir optimization. Professor Goel presented a locally developed model for forecasting. Mr. Ramalingam made a very good case for using AI, machine learning, and virtual reality, and to take us into the new world. So he said that some dams are fully instrumented and others have nothing. So maybe we need to leapfrog on that story. Mr. Kumar presented on Glacial Lake outburst floods. arguing that this is a different kind of dam break analysis, and it's very important to identify vulnerable lakes so that you are ahead of the curve of these disasters. And finally, Mr. Gupta talked about a very important operational and maintenance. It's a combination issue on dredging, and this comes up across the world. And I think in India, this is a very big issue. There was a whole special session on sediment management, and I think dredging must have come up there. And Mr. Mr. Bansi started out with a bigger question on the O&M part, and he argued that you need to plan and invest in this. He mentioned ISO 55001. I'm very curious about that particular one. I think in India, we need to start documenting not just how many dams, but also their performance, and maybe start rewarding and trying to reach more dams achieving ISO 55001, so that the O&M, the maintenance part, is also centrally there. And he raised this issue of HR, the capacity and capability on maintenance, and highlighted what I thought was very interesting, not just the top engineers who are here, but all the operational people who never make it to the conferences, and how we can invest in them. So in a closing, I would say this was a very rich session. I learned a lot, so thank you for all the modeling and technical sharing. My request and plea to all of you would be that in future such sessions, let's talk about the incentives for maintenance and excellent operations and maintenance, and how we get the funding and the valorization of those tasks, and not just for building of new things. So if we can do more of that, I think the country will be in a better place, and you can share your expertise with the rest of the world. With that, thank you very much, and please join me in thanking the panelists.
Thank you to everyone here on stage. Can we have a round of applause for them, please? Can I please request Mr. Vijay Saran, a Chief Engineer Dam Safety CWC and Project Director TRIP, to kindly acknowledge our chair and co-chair for the session. Starting with Dr. Rajan N., Chairman and Managing Director at KSEB. Our co-chair, Ms. Sumila Gulyani, from the World Bank. Thank you very much, Mr. Saran. And now I'll request the chair and co-chair if they can kindly acknowledge all our presenters on stage. Starting with Mr. Sam Bansi. Mr. Reddy. Mr. Goyal. From IIT Roorkee. Mr. Muthukumar Ramalingam, from ICDS Technology Services Private Limited. Mr. Ankit Kumar from CWC. And this is Sudhir Gupta from Hydro Design. Of course, this makes for a perfect group picture right here on stage. And ladies and gentlemen, with that, we will come to the end of this session, and we'll be requesting you all to please join us for lunch. Lunch again is served on both the levels, so everyone who's on the ground floor, we'll request you to kindly go to the convention hall, or everyone who's seated upstairs to please join us for lunch at the multi-purpose hall. We will be convening the proceedings back right here in the same main hall in 40 minutes from now. Thank you. चेक ये लीजिए.
यही चला है Drop into it. Dummy.
अरे इन्हें छोड़ के चले गए लाई साहब
Can I please request the presenters from CWC and from IIT Madras, please? So you're from IIT Madras? Thank you very much for joining back after lunch. Usually after lunch, it gets a little lethargic, but I see a lot of smile on everyone's face, which is good. And with that, we are all set to begin with our next session, which is on risk assessment. Chairing the session will be Dr. R.K. Gupta, former chairman CWC, requesting his presence on stage. Dr. R.K. Gupta is former chairman, Central Water Commission, a graduate in civil engineering from Delhi College of Engineering. He carried out Master of Technology in Applied Mechanics from Indian Institute of Technology, Delhi, and Master of Science in Hydraulic Engineering and River Basin Development from IHE Delft, the Netherlands. He obtained his PhD degree in Hydraulic Engineering from IHE Delft, the Netherlands. As I mentioned earlier, can we have a round of applause for Sir, please? The session will be co-chaired by Mr. Eric Haplin, former head of Dam Safety USACE. Eric is a registered professional engineer, worked as a dam and levee consultant specializing in risk and safety programs. He retired from the Corps of Engineers after almost 40 years of service, where he led the agency dam and levee safety programs, as well as the National Levee Safety Program. His engineering degrees from Clemson University and Oklahoma State University. Currently, he's the principal of Halpin Consulting LLC, where he works internationally with clients in dam, levee, and mining industry. Thank you very much for being here with us. Joining us for the presentations, can I please request Mr. Shane McGraw from Australia? We are still missing the applause. It will be really kind if we can get that going. Dr. C. Rajgopal from World Bank. He's not here with us. Mr. A. Shukla, DVC, NK Goel, IIT Roorkee. I'll request the presenter here on stage. Mr. Anbaz Hagen, P, IISC, Bangalore. Kavya, SWRD, Tamil Nadu. The presenter, if I may. Mr. Shiv Dayal Bharti, IIT Madras. And Mr. N.N. Rai. I'm sorry, MNIT Jaipur. Acha, CVR Murthy, my bad. From MNIT Jaipur. And Mr. N.N. Roy from CWC. Thank you. With everyone here on stage, I think we are all good to go, and I would like to hand over the session to the session chair to take the proceedings further. Sir, if you may.
Very good afternoon, ladies and gentlemen. This is the last session, today's, and last session, I think, of the conference. And after lunch session is always very, very difficult. We feel sleepy. The topic is risk assessment. It's a very valuable topic, very vibrating. So I think the topic will keep you awake. Risk management approach has been used for existing dams to calculate risk, and generally for new dams we used deterministic analysis approach, factor of safety approach for designs. But for existing dams we use probabilistic approach for calculating the risk, because the advantage is many advantages, but the main advantage is that the functional issues which cannot be taken care of by deterministic approaches can be well taken care of by probabilistic approach. So functionality of spillway and many issues which are not deterministic can be well taken care of in probabilistic approach. And we can calculate the risk to a dam failure, how much risky a dam is. When we say a dam is risky, it's not only about the structural health of the dam, but it takes care of the consequences also. We use two things to define the risk. The risk is having two components. First, probability of failure means what are the chances that the dam will fail. And the second, if the dam fails, then what are the consequences in terms of economic losses, in terms of loss of life. So it gives a complete scenario of the existing situation of the dam. How risky it is means when it can fail and what consequences a dam will have if it fails. So it's a very good approach. And the wonderful thing is that in one analysis, we can take care of all loading scenarios, normal loading scenarios and extreme loading scenarios. So it's a beauty of this approach that is given by, well taken by a risk assessment approach or risk management approach to dam. There are many advantages. Many presentations were there in the conference which have highlighted the need of a risk management approach to dam safety management. And as per Dam Safety Act 2021 also, there is a clause in the act that says that all the dam owners have to carry out risk assessment of their dams. One thing here that risk assessment is very flexible kind of thing depending upon the information available and data available. You can have different kinds of risk assessment, qualitative, quantitative, but of course, if you don't have data sufficiently, then uncertainties will be there. So these things are there, but you can always go ahead with the risk analysis and decide about the level of rehabilitation, level of instrumentation, level of different programs for dam safety management, including investment of funds. I'm happy to tell you that my co-chair is Eric Halpin. He's expert in risk assessment. He's from United States Corps of Engineers. So before we go ahead with the session, I will ask him to give some introduction to this topic.
Thank you, Dr. Gupta. I am honored to be your co-chair for this session. I sense a little bit of unease about the topic of risk assessment. I think there's some great talks lined up today to start some more discussion. All I would say about risk assessment is if you don't want to be uncomfortable with it, do it. The more you do it, the more you'll get comfortable with it. Because it's a little bit different than how we were educated and trained and grew up building dams. It's a different way to look at it, but most engineers, the world around, when they get into it, they see it as answering many of the questions about dam design and construction that they always had. So just other opening comments real quickly. We've got 7 speakers. We're going to shoot for 10 minutes per speaker. I will give you the heads up 2 minutes out before the end of your presentation. So good luck. Start your engines.
So our first presentation today is Beyond Standards to a Risk-Informed Approach for Dam Safety. It will be given by Eric Halpin. So please give a big hand.
And I'm timing myself today. So I'm going to challenge you a little bit. You see the title of this paper. Most people hear about risk and they think it's a way to prioritize investments. Yes, you do use it that way. It's not the most important way. I'm going to talk to you about what will actually change the culture of your engineering organization by using risk. And it has to do with our relationship with standards. We've spent 100 years designing and building dams based on compliance with the standard. We've also measured our safety against compliance with those same standards. And I have a little argument to make about that, so let's go. So right off the bat, this is when the culture of the Corps of Engineers changed. It's when we had finished 3,000 risk assessments. So this is 3,000 different infrastructure projects in the US, each one with a risk assessment on a typical risk chart or an FN chart, where the vertical column is probability of failure and the horizontal axis is consequences, in this case, loss of life. So when this happened to us, we stepped back. We were a little bit surprised. We had spent 100 years designing things in accordance with standards, factors of safety for stability, for exit gradient on seepage, deterministic loading criteria and hydrology and seismic. And what we found was 40% of our projects were unacceptable from a risk standpoint. So what did that tell us about compliance with the standard? There's an enormous variation in risk, 6 to 7 orders of magnitude variation. We had over-invested in some, they were uneconomical. We had under-invested in many projects. We had the wrong priorities. We were fixing projects to have them comply with the standard when they were the risk was actually low, and we were not fixing projects that had high risk. So we really had a poor understanding of where standards brought us. So let me talk a little bit about the challenges there. There's some limitations that standards bring that risk opens your eyes to. First of all, the loading conditions. Hydrologic and seismic loading, the probability of seeing those loading events is really not considered in deterministic design. So what that means is on one dam, you're going to be designing for a seismic event that has a 1 in 5,000 recurrence interval, where the hydrologic design envelope is for 1 in 500,000. So already you're creating an inconsistency in your dam about how you're designing it. And then if you own multiple dams, and there's 6,000 large dams in India, then you're designing dams, the hydrologic design varies across the whole country, and the return period on it does. So you see it creates a set of inconsistencies just in the loading condition. The same is true for the compliance with the deterministic stability approach, right? So we like to calculate factors of safety. Well, that factor of safety does not consider the full failure envelope. For slope stability, it's really the limit state where you approach initiation of a potential movement. There's many other things that work into that. And so what you can have with one factor of safety is multiple different likelihoods of that occurring. So if you're designing to a factor of safety everywhere, it's important for design, but it's not helping you manage the risk, or you're managing it inconsistently. Loading conditions, hydrologic loading. In the US, I know it's a little different here, but in the US, if you have the potential for 1 or greater loss of life, you're going to design to the PMF. And so these are two projects, both designed to the same deterministic criteria, one with an incredibly higher risk profile than the other. So this should make us stop and think about what should be the design criteria, what should you design to? So there's misconceptions about how standards and compliance with standards have educated us about safety. There's a case to be made that standards are absolutely required, but we have to do something else, because Meeting the standard, as the Corps of Engineers found out, didn't mean the dams were safe. 40% were in unacceptable risk zone. Meeting the standards didn't mean we were going to have great performance. It didn't mean there was no uncertainty. The uncertainty still is large. And then it didn't, we tended to think if we met the standard, we could stop thinking about the safety, and that is not the case. So what do we do about that? Well, in the US, 40 years ago, we don't have national dam safety guidelines, we only have federal. So the federal agencies came together and published this, and 40 years ago they said, we really should think about using risk. It's gonna solve some of the problems we have with standards only compliance approach. And so that's when it started. So the big advantages of going to a risk-informed approach are, it allows a comparison between different loading conditions at a single dam, allows comparison between different dams within a portfolio. It really gives you a better understanding of what can happen at your dam. This is the whole idea of potential failure mode analysis, is one of the most insightful things that come out of risk. And then it actually gives you a way to address some failure modes that aren't covered by deterministic standards. Internal erosion is still a phenomenon we don't know that much about. We do know that the factor safety on exit gradient is not a good judge of it, of how safe it is or how unsafe it is. Human factors, system effects, and then failure modes that are correlated. So risk brings a lot of answers to the table, and as you go forward, it's risk with standards, not risk in place of standards. The last thing I'll say about the benefits of risk is standards have always been our way of deciding this is how much risk reduction we need to get to. It's whatever, just meeting a standard, even if it's different at every project. What risk allows you to do is ask this very basic question about how far is far enough? And that is this whole level, this whole idea about as low as reasonably practicable, and the idea of disproportionality. It's really where your costs, evaluating how disproportionate the costs are to the benefit gained for those things, to give you an idea of when you can stop reducing risk. It's become the state of the practice around the world. Here in dark green, you see the places where it is fully the state of the practice, and in the light green, this is kind of where it's an emerging state of the practice. So there's not a lot of question anymore, how do modern safety programs address risk? And so what you have here in India, which is what you have in many places, is this idea about a three-tiered risk system, right? The first being a screening level. If you're going to start with over 6,000 dams, having a screening level approach to it's really critical. What that is supposed to do is tell you where you need to go, where are your issues, and where do you go conduct a semi-quantitative risk assessment to evaluate those issues. So the screening level, the top one, is 100% of your portfolio. Generally, semi-quantitative is going to be about 50% of that total. And then the semi-quantitative identifies a real issue that you have to spend construction dollars to fix, you're going to do a quantitative risk assessment. And that is generally about 30% of those that go into semi-quantitative. So at the end, QRA is about 15% of your portfolio. And I only say that because there's some people that have advocated for directly starting on quantitative risk assessment. And in India, that is about a 30,000 man-year effort. There's not enough risk capability on planet Earth to solve that. So it's really important to attack such a big problem, such a scale issue in a smart way, and it's to go through this three-tiered system. That three-tiered system sits within this bigger project approach that you see here that's already familiar to you. Is after you find the problems, how do you fix them? So that's the risk reduction phase of planning, design, and construction. And so what you see there in that graphic is on the left-hand side is a rough idea of how long it takes to get through each phase. And on the right a rough order of magnitude with dollar signs about how does it cost to get through that. I mean, the whole idea is you should be doing enough effort to inform the next phase of work. You shouldn't try to kill a gnat with a hammer. That would be using QRA for all projects. So it's to get your level of effort right. It's to inform the priority of the next queue that you're managing. And this is really where you're going to get optimized risk reduction and cost effectiveness. And this is the big driver behind the use of risk. In the Corps of Engineers, in my time there, we saved and cost avoided over $7 billion on one hand, while at the same time, we increased our funding. We made the case to increase our funding by an order of magnitude, up to $1 billion a year. Something else risk allows you to do is this whole idea of portfolio management. You don't have one project happening at one time. You don't work on all your construction projects. You have the highest risk ones. You want to get into construction because that's where you get the most immediate risk reduction. You have those that are coming behind that are going to be your design priorities. You have a lot of projects in the middle where there's an uncertainty and you're unsure if there are issues or not. So you're going to study them. Some will move on to design. Some will move down into O&M. And then the other thing this says is this tells you where and how you need to focus on O&M. The issue Sam was bringing up in the earlier presentation. So you can also look at trends. And this is kind of interesting. I want to spend a little bit of time on it. So it's the same FN chart with the 3,000 dams and levees on it that you saw on the first slide. But this is kind of how we evaluated it. After we got over the shock that 40% of our projects were high risk, we said, what is it trying to tell us? So in the upper right there, where the risks are the highest, we found a lot of internal erosion failure modes. Very little research done on this. Very little analytical models to help you evaluate internal erosion. The basic phenomenon of it wasn't well understood. So we sat down with the Dutch in a years-long process and collaborated with them on how to understand that better. So now we have a lot better path forward on that. Right below that, look at all those projects that have a relatively low probability of failure. So if you're at 10 to the -5 for a dam, that kind of sounds like the performance you'd expect out of a new dam. But we had dams with intense consequences that made us question, is that low enough? Do we need to make that project more reliable or have a lower probability of failure? And one of the things there was to understand the consequences better. So we did research with social scientists about how to understand human behavior during a flood event better. One of the outcomes of that is the tool HEC Life Sim that you use to estimate life loss. Probably the biggest thing we pulled away from this, we had so many projects that were in an unacceptable risk zone. You see them above the line there. We had to figure out what to do about it. So we set about building 4 national technical centers, one on risk management, one on essentially flood hydrology and consequences, one on levees, and one on design and construction of dam rehabilitations. And we ended up building a national team of about 1,000 people to solve the issues with all those projects that had unacceptable risk. And then, of course, it pointed some other things out. So one of them is the whole idea of how do you know when you're done? How do you now define safe? So that's a whole different topic for a different presentation, or maybe Shane McGrath might solve that one. Thank you very much.
Thank you, Eric. Very nice presentation, giving a detailed account of risk assessment carried out by US Army Corps of Engineers and Eric, and for 3,000 dams, and one very good principle of ALARP, which has been adopted for reduction of rehabilitation, for carrying out type of and level of rehabilitation for lowering the risks, and how much rehabilitation has to be carried out. It must be based on alarm principle, and so that over-investment on rehabilitation can be avoided. Thank you, Eric. Our next presentation is integrated risk management to be given by Shane from Australia. Shane? Yeah.
Thank you.
Floor is yours.
Thank you. I just wanted to start by referring to what I thought was a very good insight from your Honourable Vice President in his speech yesterday morning. He said it was so important that there is a systematic and scientific approach to dam safety management. And he mentioned specifically before we actually go into the execution of a project. And some of the things I'm going to be talking about in my speech really do come back to that particular issue. So firstly, what is meant by dam safety risk management? Well, firstly, we need to identify what is appropriate good management for all categories of risk to the safety of a dam and the activities that are needed to control those risks. And along with that, once we've identified the activities, we want to know the frequency with which we need to implement those activities. What are the standards that we are going to use to apply to the quality of what we're doing in managing those activities? And also, what are the records that we need to keep in relation to those activities? And those activities that we talk about for dam safety management are really all risk controls. They're things that we put in place to control risk at the dam, and they must be reliably managed. We've got to be sure that they actually happen. Risk management is the implementation of the appropriate good practice. So first of all, we're identifying the good practice. Risk management is then applying the good practice. And risk management, and I really want to stress this because this sometimes gets confused. Risk management does not just consist of risk assessment. Quite often people confuse those two terms. Risk assessment is typically applied to the engineering risk assessment of the physical components of a dam. And that is just one component of the full suite of required risk management activities. What do we mean by integrated risk management? So one step further, we've got risk management. What does it mean when it's integrated? Well, that's when all of the required risk management activities that we've identified are included and scoped within a single dam safety management system. Not a separate system for each activity. We have what we're looking for is a one-stop shop of what is required to be done, at what frequency and to what standard. Things like safety reviews, things like the engineering risk assessment, things like training, inspections, monitoring, etc., the whole range of activities. I want to now just talk about the Australian National Committee on Large Dams approach to dam safety risk management. And these are the Australian guidelines which are being updated at the moment. So here is a flowchart taken from the ANCOL Dam Safety Management Guidelines, and it sets out all of the activities that ANCOL consider are important in managing dam safety across the life cycle of a dam. So top left, we've got planning, investigation, design. That could be a new dam or upgrading. Top right, public awareness, role of the owner, role of government, role of emergency services. And then across the middle there are all of the activities that are important to dam safety management. Operations and maintenance, surveillance, safety reviews, risk assessments, reporting, education, information management, emergency preparedness. So those are all of the things that in the Australian context we think are important to be managed over the life cycle of the dam. Now I want to talk about asset management systems, and this has been mentioned a few times. And asset management is the harnessing and integrating of all of the activities in an organisation to create value from assets by achieving the required balance of costs, risks and opportunities. So that's pretty much aligned with what we're talking about in a dam safety management system. There is a global consensus on asset management, That's been achieved through the publication of ISO 55000, consisting of 3 standards that are shown on the screen. Key aspects of that standard: establish an asset management objectives. So in the dam context, we know what they are, particularly from the ANCOL guidelines we just looked at. Plan how to achieve those asset management objectives, how we're going to go about doing it in a systematic way. Identify the asset risks and the actions required to address the risks. So the question is, can we actually really apply that international standard to dams? Is it going to fit our requirement? So what we would need to do is identify all of the good practice program activities required to manage dam safety, map those activities to the 55,000 framework, and from that we can conclude whether all dam safety requirements can be fit in the ISO 55001 framework. And I've been through a process of mapping the ANCOL dam safety management requirements to ISO 55001. Now, I'm not going to go through this in detail. I assume everyone will get a copy of these presentations, so you can go back and look at this in whatever detail you want. But on the left there is the chapters from ISO 55001. On the right is a summary of the relevant ANCOL dam safety program management activities. And what I did is, chapter by chapter, mapped across from what ISO 55001 says should be included across to the relevant ANCOL dam safety management plan activities. And I did that for each of the chapters. I'm not going to go through that in detail. But in conclusion, what I did identify was that the dam safety program requirements from ANCOL, but there could be any jurisdiction, including India or US or wherever, can be mapped to the program requirements in ISO 55001. And that's an internationally recognised asset management standard. So it seems like a very good place to look to build a dam safety management system. So the conclusion was that the dam safety asset management system can set out what needs to be done to safely manage our dams, including at what frequency we need to undertake activities, to what standard we should undertake those activities, and what records are required. So if we can do all of those things, we've achieved what I described earlier as integrated risk management. So that's just a simple graphic of what I've been talking about. The dam safety context, your jurisdiction, and where the good practice would come from in your culture or from your laws. That then identifies the dam safety management program activities, good local industry practice. We integrate that into ISO 55001. We create a dam safety management system, and we have an integrated risk management program. Advantages of doing this: it minimises the chance of risk control activities not being done, falling through the cracks, if you like, or not being done to the right standard. And that can happen for a lot of reasons, but changes in organisational structure or personnel can result in things being forgotten to be done or missed. It's robust and sustainable, provided it has the support of senior management, regular reporting and performance reviews, with any required improvements implemented and monitored. Good record keeping is absolutely required, and that makes it readily auditable that things that should be done have actually been done. It can be connected to 3 levels of audit, looking at are the activities actually being done to the frequency? Secondly, are they being done to the right quality? And thirdly, are they the right activities in a decreasing level of frequency? Now, I want to talk a bit about engineering risk assessment in Australia. So this is moving on from risk management, which incorporates a whole lot of activities I mentioned earlier. This is the engineering risk assessment, which you can see on that graphic, which I've come back to, is only one element of risk management for a dam. It's just one part of it.
2 minutes.
Thank you. And looking at the guidelines, In Australia, we have those 4 levels of risk assessment, screening to very detailed. Typical detailed risk assessment, you'll see on the left side in the middle, that's the consequence side of the equation. In the middle is the probability side of the equation. On the right, I've highlighted engineering, traditional engineering analysis, and using that to determine the adequacy of the current dam to design standards. And those 2 things in Australia we call the safety review. Looking at a portfolio process on the right-hand side, and this is important because we're looking here at a staged approach using screening risk assessments at the top. We rank the dams in order of risk, and that sets priorities for more detailed studies, progressively undertake those detailed studies, those are the standards-based studies, and progressively update our risk assessment. Again, those activities on the right are safety reviews. So we do the screening risk assessment based on whatever information is readily available. That provides our priorities for dam safety reviews. We then go into the safety review process. We then refine our risk assessment. We then produce risk reduction measures to meet our dam safety objectives. And we finish up with a prioritised risk reduction program. What is a safety review? It varies considerably between jurisdictions, but you can see and read here what it is in the Australian context. It's basically evaluating the existing dam in its current condition. So we need to characterise the foundation, the materials in the dam, its structural stability, and we test that against current seismicity, current hydrology, and check the stability of the dam against those conditions. Why do we need it? Well, a risk assessment process to assist in deciding on the safety of a dam that requires a detailed risk assessment. You cannot do a detailed risk assessment without the information that comes from a safety review. That's probably the most important thing I'm going to say today, because a lot of people get quite confused about that issue. And in Australia, the safety review obviously precedes the detailed risk assessment. Screening level risk assessment, where we don't have that detailed analysis from safety reviews, good for priorities for safety reviews and detailed risk assessments, identifying the need for interim risk reduction measures, and providing an initial overview of the portfolio risk position. So to conclude, integrated risk management, yes, we can do it. We need to identify the safety requirements that are applicable in our jurisdiction. We map those to 55,000. And again, I'm just repeating that risk management is not only engineering risk assessment. It's a whole range of activities that I've mentioned a couple of times now. Engineering risk assessment requires a staged approach to identify priorities for further investigation and analysis. A detailed risk assessment should be preceded by a safety review. Thank you.
Thank you, Shane.
Thank you, Shane. Very good presentation. You talked about the need of integrated risk management system by creating asset management tool. We should have data, dam safety management systems to have this. Thank you once again. Our third presentation is about comprehensive risk assessment for Mathan Dam hydrological risk, to be given by Professor N.K. Goel from IIT Roorkee. To be given by Abhishek Shukla, sorry. Yeah.
Good afternoon, one and all. So first of all, please accept my heartfelt thanks for the organizers to accept my paper on this. This was also my thesis topic, which I done under the guidance of Professor N.K. Goel. So risk, I think this is the most heard word in the past 2 days, after dam and safety, of course. So About risk, a lot has been told, and so I am not going to add further. It's mainly because of the aging and deterioration, lack of maintenance is the primary factor. But change in the socioeconomic condition after the dam has been constructed is also one of the factors which we need to encounter. We will see in our case study. Population growth and revised guideline also add to the present risk in the dams. Now, comprehensive risk assessment of dams promotes risk-informed dam safety, as we have heard again. Why? To optimize the resources and funding for rehabilitation, as well as need for further studies, any interventions, investigation that we need to do to reduce uncertainty. The assessment obviously involves hazard identification, risk assessment, and then categorization and necessary interventions to reduce the overall risk associated with the dam. This is the Indian context. Of course, this is the report of NRLD 2019. There has been some updates recently. So at that point of time, 5,745 large dams were there, and the 20% of them were more than 50 years old. Now this 20% means around 1,200 dams, which we have not covered under DRIP 1. And obviously, when we combine the DRIP 2 efforts, it will not be covered. So yeah, there are old dams. So naturally, we need huge investments for then repair, rehabilitation, and the resources are limited. So risk-informed decision. As of now, only one dam has the document on risk assessment. That's the Bhadra Dam on Karnataka, which I could gather through public resources. And however, the Act mandates that risk assessment of all dams to be completed by December 2026. This is a Hurricane task by itself. So now come to our study area. This is the catchment area map of Damodar Basin. We have a 25,000 square kilometer catchment, and we can see that it is roughly a fan-shaped catchment. All the dams are in the upper section, and the water which we release, or which during the flood case we release, goes to the planar area of West Bengal, which is highly populated zone. Bardhaman, Asansol, Kolkata, Havra, these are very populated, thickly populated areas. The upper section is the section which we are studying. It's the Maithan Dam section. There it is all again 5,400 square kilometer for Maithan only, but combining with the Tilaiya catchment, which is a reservoir shown in the very upper section, it goes around 6,400. So the dam has a gross storage capacity. This is the present gross storage capacity is 845 MCM, and as per the height and the dimension, it qualifies for PMF. So it was completed in 1957. The dam is operated, the reservoir is operated through a rule-based operation policy. And we do have a dedicated flood storage of 326 MCM. So this is a dedicated storage, and we already have a dynamic flood storage before we actually fill up the dam after the end of monsoon or near to the end of the monsoon. Now, the approach was, one more thing that we are, in this study, we only took hydrologic risk assessment. So obviously we covered the normal as well as hydrologic extreme scenario, but the seismic and other parts were not covered. We followed the guidelines for assessing risk assessment published by CWC in 2019, and quantitative risk analysis was carried out through an event tree-based risk model. From the review of past inspections and through through studies by third-party inspections, obviously under DSRP, we found that overtopping failure would be the credible failure under hydrologic risk scenario, but there would be a large releases which is greater than the downstream channel carrying capacity. Although it is a non-failure, but it may cause risk, and for that the studies were taken out. Now, the likelihood of overtopping failure or a large release would depend only on the three functions: inflow coming into the dam, the already existing levels, and operational aspect of the dam for releases. So what we need is a large amount of data to go for probabilistic analysis. We already have data for 62 years, which includes daily reservoir data, daily inflows and outflows. However, we undertook studies from different sources. So Government of India reports way back from 1945, some Bar Ayog report, UN report and all. And through all those studies, we come to know about the significant floods since 1823. So instead of 62 years flood, we now have information of 200 years flood. Also, the previous hydrological studies were referred to, and other studies include understanding reservoir operation protocol, releases pattern based on flood cushion occupation. This is very important that we release from our dam based on flood cushion occupation and not simply by through a theoretical model that we normally use for any flood routing cases. We will show in our study. So this is the risk model architecture. This is basically the event tree architecture that I discussed. And for each of the analysis, like for the flood analysis, estimation of annual accidents probability were carried out through different data set. And for the same, two of the Python modules were developed, including trend analysis and statistical distribution. Analysis was also done through RMC best fit. Accidents probability for reservoir pool level under normal as well as operating scenario was carried out. Gate reliability analysis through a fault tree analysis was computed, and flood routing for combination of all those scenarios. So there would be 560 cases of flood routing that we need to carry out. So again, a Python module was developed. Failure probability analysis for overtopping and failure probability was carried out to understand as per the result of the flood routing. So we took whether the maximum water level goes beyond the breaching dike level. If yes, then overtopping, otherwise non-failure releases, which we release through the gate only. And consequence estimation, which is computed by two methods. So probable loss of life was computed, as well as economic losses were computed. Again, a custom developed QGIS module was used. So finally, the societal risk and economic risk was computed based on the failure probability and probable loss of life and economic losses. So for annual accidents probability of floods, so three methods as we discussed. One was flood frequency analysis for annual maximum series of 62 years. Again, peak over threshold series for of more than 2 lakh, and risk management centers RMC best fit data. So ultimately, we found this result, which shows the annual accidents probability of original design flood to the tune of 10,000 year return period. But for the PMF, it goes around 2 lakh year of return period. So for the analysis in the event tree, the floods were categorized and 14 flood scenarios were considered, ranging from 10 year to 1 lakh year.
2 minutes.
Okay, sir. Similarly, pool level accidents probability were studied, and both operational and non-operational scenario was considered, and 8 discretized levels were discussed. This was about gate reliability and fault analysis were carried out, and we divided the scenario into 5 conditions. From all these analysis, we have a combination of 560 flood routing cases, and this was again developed through a Python module and using modified pulse method. Now this is the normal flood routing method which anyone would use through a book, but this is our reservoir operation policy, where we operate based on existing flood cushion. So the releases differs. So the peak reservoir level and outflows were checked for overtopping or non-overtopping failure. So the overtopping failure probability came to the tune of 9 to the power 9.5 to the power 10 to the power minus 6, and similarly other probabilities were computed. This also gave us the idea of what are the different flood scenarios that we need to take based on the initial conditions as well. So consequence estimation was computed through a custom module developed in QGIS. So this was for probability of loss of life, and similarly, economic losses were computed. We followed supreme model as well as global flood depth damage functions. So these are the result. Under the case of overtopping, the failure is given, but the probability of loss of life is around 18,000, and damage value is around 12,400 curve. But the interesting part is the bottom one. This is the portion where we see that it is less than the channel carrying capacity, existing channel carrying capacity, but still we have a losses of around 1,000%, and in terms of crore, 2,242 crore. So that was a big takeaway. So basically, we also observed that if all the gates are in operational, there would not be an overtopping. So we need to ensure that gate remains operational. Incremental societal risk and again shows that non-structural intervention would be more applicable. So implementation of EAP and stakeholder participation, early warning system needs to be developed. And understanding the operational aspect of the dam is crucial for any such analysis, and that was depicted in the flood routing cases. Event tree was provides a simplification of the calculation and hence used, and different module that we developed helped in substantially reduce the computation time. So there it is. Thank you.
Thank you, Mr. Shukla, giving the detailed account of quantitative risk analysis for hydrological failure of moat for Mathan Dam. It was in detailed. So now we have the next presentation on seismic safety assessment of Sholayar Dam to be given by Ms. Kavya from WRD, Tamil Nadu.
So very good afternoon. So my topic for today is seismic safety assessment of Sholayar Dam. So this is the outline, and the objective of the study was to estimate peak ground motion parameter for the dam site in consideration using deterministic approach while accounting for regional seismotectonic parameters. The dam site in consideration is Sholayar Dam, situated in Coimbatore district of Tamil Nadu. The dam is situated across Chalakudi River. And as we can see, the Indian standards IS 1893 for earthquake-resistant design of structures. The zonation factor for Coimbatore district has been changed from 1962 to 2016. It has been shifted from zone 1 to zone 3. And in the draft version of the code, Coimbatore district has been placed in zone 3 with a PGA value of 0.3G. So this study primarily will calculate the PGA value by considering the regional seismotectonic parameters. So the methodology is like this. The first step is the selection of seismic study area. Then we'll be calculating the seismotectonic parameters for the selected study area. And the maximum moment magnitude is estimated by two different approaches. And also the future rupture zones in the region are estimated. And finally, all these inputs are used in the predictive equations which are suitable for this region. And the ground motion is estimated. So the selection of seismic study area is the first step. According to the International Commission of Large Dams, selecting seismic parameter guidelines, a minimum of 100-kilometer radius around the dam site has to be considered. Whereas, if there is any area-specific attenuation characteristics or past earthquake history, that also has to be accounted. So going by the past earthquake history, Coimbatore, very near to this dam, in 1900, earthquake of magnitude 6.3 was recorded, and the epicenter of the earthquake is at 56 kilometers from the dam site. So the influence distance of that earthquake was 480 kilometers. So seismic study area of 500-kilometer radial extent has been considered for this study. The seismotectonic data sources were taken from these sources. So the first step after obtaining the data is to decluster the data. Declustering mainly divides the foreshocks and the aftershocks, main shocks. So the algorithm adopted here is Gardner and Knopf method, which is a dynamic space-time windowing technique. It was used to decluster the events. And the next step is to assure that the data is complete. So there are different approaches to estimate the completeness of the data. The methodology adopted here is STEPS method and cumulative visualization method. So by going by these methods, the completeness of the data was ascertained. As we can see, the data was classified into various magnitude bins, and the completeness period and the interval for these bins were estimated. Using the completeness intervals, the Gutenberg-Richter relation A and B parameters were obtained, which are the regional seismotectonic parameters. So the B value obtained here using two methods is using the steps method, it is 1.2, and using the cumulative visualization method, it's 1.22. So a B value of more than 1 indicates that the area is more prone to smaller magnitude earthquakes. So this is the Gutenberg-Richter relationship plot. This is the comparison of the B values for different from literature for southern peninsular India. So the maximum moment magnitude estimation. So two cases were considered here. The first case is the maximum magnitude observed at each fault. That is, considering the past earthquake history, the earthquakes were assigned to the faults in the 500-kilometer radius from the dam site. And the second case is based on a rupture-based method, wherein the percentage fault rupture was plotted against the length of the fault, and a maximum percentage fault rupture enclosing the different length segments was selected, and the maximum moment was back calculated from this PFR value. So the next step is selecting ground motion prediction equations. So since for peninsular India, we have very limited number of ground motion prediction models available, we have adopted the Eastern North American model, since the seismotectonic characteristics of Eastern North America is very similar to that of peninsular India. So in this study, 4 peninsular India equations and 6 Eastern North American equations were used. So these are the list of the ground motion prediction equations. The equations were assigned weightage using the log likelihood method, wherein the data support index was calculated, and for the equations for which the data support index was a positive value, the weights have been assigned. So these weights were further used to estimate the peak ground motion parameter. So this is the methodology that was adopted to find out the probable earthquake locations. In this, we have considered 3 main conditions, wherein the location must have experienced at least one minor earthquake, that is magnitude less than 5 in the past 20 years, to indicate seismic activity. And there also must be a defined seismic source within 10-kilometer radius of the epicenter of the above mentioned minor earthquake. And also the location should not have experienced any major earthquake that is magnitude more than 5. So based on these criteria, 19 locations were identified as probable future rupture zones, and the peak ground acceleration value was also calculated for these rupture zones. So the final results are presented here. Using the maximum moment, radius, and the regional parameters, these were inputted into the ground motion prediction equations to obtain the peak ground acceleration values. So as we can see, for the observed magnitude, it was 0.41 G, and for rupture magnitude, it is 0.44 G, which is higher than the codal provision of 0.3 G for the Coimbatore district. So this is some comparison with some previous studies that have been done in peninsular India. So these are my references. Thank you.
Yeah, thank you, Ms. Kavya. Very nice presentation and very detailed account of safety assessment for earthquakes for Sholaya Dam. Thank you very much. Our next presentation is basics of earthquake risk estimation of dams, to be given by Professor Shiv Dayal Bharti.
Yeah.
Yeah.
Am I audible?
The floor is yours.
Yeah, thank you. I have 10 minutes. All right, thank you. Thank you. Thank you, Chairman, sir. And good morning, everyone. I know I'm the last but one presenter in this 2 days conference. Before I actually embark on the presentation, there are 2 things I want to highlight. That we have been talking about the word risk, quite often for 2 days. And we must understand that for the dam safety professionals in India, I'm talking about practitioners, not the academia, and there is a distinct paradigm shift ever since we have enacted, notified, and started implementing the Dam Safety Act. There is a complete chapter on, they call it comprehensive risk evaluation. So Dr. Gupta will agree with me. So there has got to be some departure in thinking, from repair and rehabilitation to risk assessment and retrofitting. So that is the one thing I want to underline. The second thing is that the objective of this presentation is to demystify the whole concept of risk assessment. We have been using this word very lovingly, maybe sometimes loosely also. And essentially the term, originated from the finance and investment and all those things. So when we talk in terms of risk assessment in dam engineering, we need to, bear the term, understand the nuts and bolts and details of it. So the whole objective is about, the presentation about that only. And most of the cartoons in the presentation have been taken from a book that was released yesterday by Honorable Minister in Jaipur. So if you miss some cartoons, don't worry, the book will be available on our website for free downloading. Okay. So next, please. So I have to do what? Yes. Estimation of earthquake risk. Earthquake pose, why? See, sometimes we get that why earthquake? Because earthquake is the most severe of all the See, this is essentially about structural risk. So earthquake is the most severe of all. So you have to be mindful about the earthquake risk. Next. So this is the parent equation. To understand risk or to assess risk, you have to understand hazard, vulnerability, and exposure. Hazard is what the nature is imposing on us. It can be surge, it can be earthquake, it can be cloudburst, it can be anything which imposes load. Vulnerabilities of the structure. That means in the current case, the dam. So far we have been modeling in a very simplistic manner. And exposure is of what is getting affected because of that. Hazard and vulnerability combined gives you the risk. Sometimes we tend to express exposure also risk. So this is the disaster. So when you have a high hazard and a very vulnerable structure, and what is being exposed is the man-made environment, the natural environment, and the ecosystem. So that is the exposure. So you are actually risk. So the risk to the structure leads to the adverse consequence and risk of the what is being exposed. And the Dam Safety Act demands, I'm not saying the word mandates, the quantification of the risk assessment. They use the word comprehensive dam safety evaluation, but just the word only. And here, since we have a large stock of dams, you have to figure out which dam is going to give you higher consequences in terms of exposure. So if you have higher consequences, you have to take a higher value of demand, the PGA value. That is what the graph tells you. If you have a very special structure, can I use the pointer? If you have a very special structure which you can't afford to risk, then you have to go high PGA. Otherwise, you can just, for a smaller structure, smaller dams, you can go with that. So that is again represented in terms of return period. Those they do probability, they understand high return period means the stronger or the severe earthquake. Yeah. This is the loading. This picture without any quantification shows you what are the loading condition on a gravity dam. And we are taking a gravity dam. You have a zone of cavitation, you have an excitation, then there is atmospheric pressure. And when the dam goes and back and forth, over and above the hydrostatic pressure, you have a dynamic pressure, which is actually oscillating. So there is a zone of cavitation also. So you have to understand that when you consider the seismic excitation. So that is a likely area where the concrete is like to be scooped out. And mind you, that is actually underwater. So this is the one more thing that we must learn to understand is that when you do risk assessment, we must learn to do the what we call potential failure mode analysis, or some literature call is failure mode analysis. Some call it damage analysis. There's something. So whether it's a strength issue, stability issue, leakage issue, or something, the movement, settlement, seepage, all those, and you have to model the complete system, the dam, the foundation, and the reservoir. Overtopping is the problem. See, spillway gates is the problem. Yeah, and when you do the vulnerability assessment, there are three vital components that you have to do the field study. Your finite element model or your numerical model is as good as you assume. But if you do the model testing of the dam, which most of the developed countries have been doing, and we propose to do for our pilot study, just to fine tune, verify, validate your numerical model or what you call finite element model, you have to do the field studies so that your mode, shape, frequency, and all those things are, at least first couple of modes are telling. Then you have to develop your analytical model, which actually contains the complete system, the dam, the foundation, and the reservoir. And the last and most sophisticated and costly item is that to figure out the failure or damage mode, you have to do the scale model testing of a dam, putting it on a shake table, which people are doing in the Western or the industrialized world. The Pine Flat Dam is the one which has been studied extensively. And this is the, what do you call, 3 studies, detailed finite element model of the dam foundation reservoir system, and how do you pick what is the, the seriousness of the consequences of your dam. You have to figure out. Yeah. So the top one is the fragility plot. The lower one is the reverse of it. That's the reliability plot. When you have to do 6,000 dams risk analysis, risk assessment, or comprehensive risk assessment, I do not know what do you mean by comprehensive. What I understand is that you have to do all kind of loading scenario, including surge, flood, debris, everything. And so when you say that if your dam is of a serious nature, then you have to do, the red one, the strongest of the shaking you have to take into consideration. And you have to do dam break analysis. What they have done in Mathon Dam is that essentially inundation studies. Inundation in case of a breach, and what failure mode you are considering, how much water is going to pass through the dam. There are people under risk, there is ecosystem under risk, and there is a built environment under risk. So that has to happen, but that has to be combined with what is going to be the the first mode of failure. The first mode of failure cannot be just washing away of the dam. It has got to be something, because if your hazard is a really serious nature, then it has got to be a slightly, you can say, harmless mode of damage. So that is what the dam owner should estimate quantitative earthquake risk themselves. That is what I'm marking it red, that is what the Act says. Thank you very much. I suppose I am within time. I can take questions. You want me to go back to the slide? You want to take pictures? We'll give you the full presentation. Don't worry. Oh, still you want to take a picture with the chair and co-chair sitting? Wonderful. So that gives me an opportunity to speak more.
No, thank you, Professor Bharti. Good presentation. Thank you, Professor.
Shall I close?
Yeah.
Thank you.
So now we have the last presentation of this session, and I think of the conference. This title is Importance of Sensitivity Analysis in PMF Estimate of Large Catchments, a case study of Sardar Sarovar project, to be presented by Mr. Nityanand Rai. He is the Director of Central Water Commission in New Delhi. Mr. Rai, floor is yours.
Thank you, sir, and good afternoon, everybody. Though this topic is not directly related with the risk analysis, because no risk analysis I have carried out here, but it is a very important component of the risk analysis. And especially for the large catchments, what are the uncertainties and how are you going to take a decision? So in this paper, we have tried to highlight all those aspects. This is with the case study of Sardar Sarovar project, and this is a very interesting project. This project was designed for 1 in 1,000-year return period flood, because when this project parameters were being finalized at that time, our BIS code was not available, and at that time it was
purview of the designer. Designers used to take some flood of 1,000-year return period. For some projects, PMF was also estimated. So in year 1980, this 87,000 flood was 1982, some 87,000 cubic flood was adopted. This is 1 in 1,000-year return period flood. And after that, PMF was started to, people started to estimate the PMF also. And a lot of study regarding the PMF was carried out, and this project was financed by the World Bank. So a lot of experts, meteorology and hydrology experts from World Bank were also associated with this project. So the first estimate for PMF was made in 1981, in December 1981. And this was based on the flood frequency analysis of the about 40 years data of the Reservoir, which is something around 14 kilometers downstream of the Sardar Sarovar project. And estimated flood was of the order of 1,02,000 cubic. Then this was perhaps not agreed by the World Bank experts, and World Bank experts suggested that one storm which occurred near the coast of the Gujarat in 1927, at the place, the eye of the storm was at the place that is Dakor. And considering the Dakor storm, all the analysis were carried out, and this DDRP finally recommended, based on all these analysis, a flood of 1,71,100 cubic. So this was a very interesting case, and this is what you are seeing, the location of Dakor I have marked here, and this is the catchment area of the Narmada, river Narmada at Sardar Sarovar project. And most interesting part that 540 kilometer transposition was carried out if you are considering Dakor storm. And at that time, WMO guidelines were available, but I don't know why those aspects were not taken into consideration. Even our IMD never agreed for Dakor storm, but it was finally taken. And one fictitiously high PMF of 1,71,300 cubic was recommended, making this dam hydrologically unsafe. We have this Sardar Sarovar DSRP. They told project authorities to contact Central Water Commission, and in January 2023 they came to us, and finally we started analyzing the whole scenario. So this project, this qualifies for 3-day storm, because considering this basin itself around the project site, the catchment area is of the order of 57,000 cubic, and we are having flood estimation reports also. So those flood estimation reports, and we are having PMP Atlas. That PMP Atlas is the latest publication, year 2015 publication. In that, all the severe storms right from year 1906 are available, and you can get the ISO heights of all these storms. So here we consider 52 subcatchments, and these are the transposition limits as per WMO criteria, and this criteria was establishing at that time also. So here clearly it is taken for the projects having catchment area more than 50,000 square kilometer. One has to be very careful for selection of the storm, transposition, and for this storm track, and all those parameters need to be studied carefully, and then decisions should be taken regarding the PMP value. So what we have done, because a lot of studies were carried out, we have considered all the historical storms, like 3-day storm Garandengari, then Golkund storm, 3-day Dakor storm, 3-day Panchmani storm, 1974. This and you see the depth also 1086, 977 at the eye of the storm, and here in this case 630. We were knowing what we have to take, but it was necessary in this report to put all those storms, and these are the locations, like that is the Dakor, this is Golkund, and this Panchmani. Panchmani is just inside the catchment itself. And one by one you can see quickly. I will show you, like here the at the eye the depth is 1086, but when we transpose, because its isohydral extent is like that, it cannot cover the entire catchment. This is elongated catchment.
So we have got the catchment representative transpose depth 182 millimeter, which is too less. So though 1086 number millimeter is becoming immaterial for this case. Now go for the second one. This is the 3-day Golkundi storm. This we have almost covering the 100% catchment. Rainfall depth at I is 977 millimeter, and what we have found, the catchment represented PMP is 285 millimeter. Now third one, this is the 3-day Dahor storm. This is critically transposed. It cannot be transposed like that, but since earlier it was done, so we have again carried out, because we have now moved the eye of the storm 540 kilometer, while the limit is 200 kilometer. We cannot go beyond 200 kilometer. So we have found 341 millimeter, that is the catchment representative PMP. Then we have found this, if you are considering 3-day Panchmadi storm, here we have found catchment representative PMP is 298, and what we are seeing is more than 300 millimeter rainfall PMP value we are getting in more than 30 subcatchments. So it means this storm could be a prominent storm for any PMP study. Then this is all this, how we carried out body movement and all those things, 1 day, 2 day, and for each subcatchment. And here another important, because this Sardar Sarovar is elongated reservoir, something around 240 kilometers, and number of other reservoirs are there. Also there, Indira Sagar project, Bargi reservoir. So a number of routing reaches will be there in such type of model if you are making quasi-distributed hydrological model. So for those reservoirs, we have considered critical condition. Inflow is equal to outflow. So for those reaches, we have considered only lag model. That is going to be the most critical one. And for rest of the reaches, we have considered this Muskingum method, where we have considered almost kinematic wave velocity type parameter for the velocity, taking the value of K and X. And these are the values of the lag parameters which we have considered for all those reaches which were lying in the reservoir. And these are the normal Muskingum routing parameters. And sensitivity analysis we have carried out. And you can see these are the results of the sensitivity analysis. We have considered 3-day Golkundi storm, 3-day Panchmadi storm, then Dahor storm. And what you are getting, this flood values of 103771. And for Dahor storm, what we found 10515. And here loss rate also, we have taken the minimum on. Still we could not get 1,71,000 cubic. And based on that, what we have recommended, that a value of 1,71,000 cubic can be the optimal value. And considering another important aspect, if you see this entire basin is linear. And for Indira Sagar project, already a PMF value of 89,000 cubic, and that was existing. But considering all those things were neglected and 1,71,000, that is not possible. If consider the response of linear basin also. Yes, sir, I am just completing. Thank you very much. And after that, we have carried out this reservoir routing also. And you see, earlier we were getting a freeboard of 55 centimeter. And a lot of, if you go for risk analysis for such type of freeboard, you will put Sardar Sarovar on a big risk mark. But finally, if you have carried out proper sensitivity analysis in a sensible way, now freeboard is almost 5 meter. Thank you very much. So conclusion, transposition to catchment larger than 50,000 square kilometer may result unrealistic excessive PMP. This may result a severe unrealistic situation of flooding that is not experienced by the catchment. Hence, in case of large catchment, the utmost care should be taken in storm selection and transposition. For PMP computations, a rational selection of storm considering the storm track, influencing factors, that is very important, of storm centering and storm transposition limits need to be decided carefully in order to obtain a reliable level of PMP depth over the subcatchments and consequent PMF estimates through a detailed sensitivity analysis. Thank you, sir.
Thank you, Roy, for a very passionate presentation. Thank you very much. So we had all the 6 presentations today, very good presentations. Now it's time for some questions. If we have some questions from the audience, our experts can give the answers related to their papers or any general question. Please raise your hand. Yeah.
Hello. I am S.K. Manik, Scientist D from India Meteorological Department. My question to Yanendra. Yes, already you told that IMD never consider any storm surrounding away from the 200 kilometer. But you have transposed that storm from apart from more than 200 kilometer, it is 500 kilometer, it may be. And second thing, when you are studying for the Sardar Sarovar, so in the upper catchment, there have the other dams are also there. So for the Sardar Sarovar, you may consider only either by integrated studies or by only for the Sardar Sarovar, whichever is available on the lower catchment. Means, considering, well, you have to consider that the upper dam that should not be provided the water for that. So you will get the better result and possibly you will get the more value for PMP also.
We have considered the core storm because I have already told you the core storm cannot be transposed but earlier because it was considered, that's why we have considered, and we have moved it by 540 kilometers just only for showing the results purpose. But actually the PMF has been recommended based on the Panchmari storm and all the storms which have occurred in that area, because in the PMP atlases you have considered, I have shown you, we have considered 4-5 storms. All the storms have been considered, and based on upstream projects, because for upstream projects we will consider reservoir routing only if dedicated flood cushion is there. If there is no dedicated flood cushion, then your most critical condition for the PMF estimate will be your reservoir is at FRL, and whatever the flow is coming, that you are releasing into downstream. That way we have carried out. And again, one other important aspect, in channel routing we have considered lag routing for the reservoir reaches. It means no attenuation, only translation. Thank you very much.
One more thing is one more thing is that because this is east-west oriented catchment, and also there have the rainfall variability is also there. So for that case, you have to consider it is by part also, only considering the catchment.
Because this we have rotated this storm by 20 degree. You see the orientation of the by 20 degree, and I have shown you ki overall 30 subcatchments out of 52 we have experienced more than 300 millimeter. And if you are getting more than 300 millimeter for any count based on 400 design flood study, I can show you this is your very good estimate of PMP.
But we never consider more than plus minus 20 degree rotation.
That is the maximum. That is maximum. So that we have considered. Thank you.
Thank you, Roy. Any other question? Yeah, there. We would like to have a short question and short answer. Considering the paucity of time.
My name is Pradeep Thakur, Director, Central Water Commission. My question is to Mr. Shri Shukla ji. At lower discharge, how can the risk be more than higher discharge? In one of your slides, the discharge was something around 6,000 QMax, and all the risk factors were coming more as compared to 13,000 QMax.
That was not the discharge. The discharge was discharge has been classified on the level of 8 levels. One was overtopping, another were not overtopping but high releases. The value that I have shown is of the probable loss of life and incremental loss of life. So incremental loss of life were more, not the loss of life were more. Incremental loss of life were more. Incremental loss of life is with reference to previous study that we have taken. Similarly, incremental losses in terms of economy was again more in the lower band, which reflects that flood inundation, the flood zone, which was earlier there, has now been mostly occupied due to socioeconomic growth. Thank you.
Any other question? Yeah, this is, I think, the last one. Yeah.
Thank you very much.
Short question and short answer.
I know they should be short.
Yeah.
Yeah, I normally summarizes. Thank you very much, and I'm really interested with all the sessions which have passed through. I'm responding to one of your callers who said that any questions. My questions are about the previous two sessions, maybe after the lunch, before the lunch. Yeah, I did not get the right time to ask my concerns. One of the interesting part which I would like to know, there was a presentation about dredging of the reservoir. That to me, it was very interesting because in my country have number of reservoirs which are silting up. So I would like just to know what are the basic requirements to determine which method for dredging should be used. That's very important. Another thing pertaining that I would like to know exactly more information pertaining dredging and the company related to that so that I can outsource that requirement. Thank you. Another thing which I would like to know on the previous also presentation is about reservoir forecasting. That was very interesting also to me. He said that you can make a focus of the reservoir, but the reservoir, it has its own component, such as sediment. So based on that, is there an expert who can say something on the reservoir forecasting vis-a-vis sediment accumulation in the reservoir? So if there is such kind of study which are being done anywhere, maybe you could share that. To me, it seems to be a little bit difficult, but it is my requirement as well. Thank you.
Yeah, both the questions are not related to this session. Regarding the dredging, I do not know who gave the presentation in the last session about reservoir.
As per your call, thank you.
Yeah, you can contact the presenter. And regarding second question, you have around you are asking about the sediment yield and means deposition of sedimentation in reservoir.
Yes, the law was a.
There are standard methods for estimation of sediment yield, and there are methods to find out how much siltation has occurred in
It's
the
about
reservoir.
forecasting. That's how difficult it is. It's about forecasting.
Flood forecasting. You
Yeah,
want to
that's the
ask?
keyword.
Yeah. That Professor Goel.
Hello. Yeah, regarding that inflow forecasting in the reservoirs, the bathymetry survey they are conducted, and based on the bathymetry survey, the elevation area capacity curves they are prepared. And based on that area elevation capacity curves, the inflow volume is computed. And based on that inflow volume, the reservoir level is forecasted.
Thank you very much. I think my question is difficult. My difficulty is that in the reservoir, we can forecast the inflows. The inflow is the runoff, but the runoff cannot be separated by sediment or silt. Can someone forecast also the silt accumulation in the reservoir? That was the difficult question. I think you can try. All of those I know about the mathematics and everything I know.
Yeah.
Correct. So that was my question.
Yeah. I think that sediment forecasting is difficult thing.
Yeah. So I wanted if there is someone who has done that. Because this is a
Even the
congregation.
flow in the reservoir is computed indirectly by the water balance equation and this area elevation capacity curve. There is no direct method of which could measure the inflow into the reservoir. It is always computed indirectly.
Okay, thank you very much. Okay, thank you.
I think this is the last question. We have short question.
Thank you, sir. Thank you, ma'am. My question is to Kavya, ma'am.
Mic,
Kavya,
please.
ma'am.
Ma'am, you have selected 6 GMPs from peer NGA.
Please introduce yourself.
My name is Naveen. I am a master student in dam safety and rehabilitation at IIT Roorkee, sponsored by Central Water Commission. So my question is to Kavya ma'am. Ma'am, you have used 6 GMPs in your DSSA of Coimbatore 1 dam. So have you compared seismotectonic settings of Coimbatore region and the PNG regions? Because mostly the ground motion depends on the which GMP you have used. If the seismotectonic settings are different for different regions, then there will be different values of ground motions.
Sure, sir. This was derived from literature. It has been proved that the seismotectonic characteristics of peninsular India matches closely with Eastern North America. This was derived from literature. So that was there in my slide also.
And one more question: if any probability of accidents?
Yes, sir. We have also. I had also done a probabilistic hazard analysis. So I'd considered different probabilities of accidents and the.
Maybe 10% accidents in last 50 years. So.
No, sir. Not for the last, but for the. This is a futuristic calculation. No? So we have also done a probabilistic analysis, and the results were closely matching.
Okay. Thank you. Thank you, ma'am.
Thank you very much. So in this session, we had 6 presentations, very good presentations, and we talked about risk assessment to dams, existing dams. We had good presentations from Eric, who talked about the concepts, and whatever he has done, he has the experience of 3,000 risk assessment in USA, and he talked about the over and under investment based on the risk analysis. So we have to be careful, and we have to calculate the risk, and based on that, investment decisions regarding rehabilitation level has to be done. Thank you, Eric. We had a good presentation from Shane. He talked about integrated risk management and engineering risk management, 2 different concepts he said. And he talked about the dam safety management system, which requires for this integrated risk management. Some good presentations regarding quantitative risk assessment and seismic assessment for dams, Sholayar Dam, very good presentations. And we had some presentation from related to hydrological risk for Mathan Dam, very good detailed account of quantitative risk assessment. And lastly, we had a good presentation from Rai, very passionate presentation, and he talked about the PMF estimation for Sardar Sarovar. We have in India large amount of large dams, around 6,000. And as per Act also, we have to go ahead for risk assessment. But that doesn't mean that we have to do the risk quantitative risk assessment or detailed risk assessment immediately. We have to carry out the portfolio risk assessment first, and we have to decide the level of risk assessment to be carried out. Not all dams require detailed amount of risk assessment. So portfolio risk assessment can be done very fast, and each dam owners should collect the data required for that, and that can be done by experts or individuals who knows this portfolio risk assessment. And after that, based on the credibility of a potential failure mode, we can decide whether we have to go for certain investigations, studies to decide the credibility of the potential failure mode, or we can go ahead with semi-quantitative risk analysis, and that's all. Only few dams will require quantitative risk assessment that is in detail. So that also based on the existing studies or future studies and investigations done. So if we have full data, and if we need a quantitative risk assessment also to be done, it's a mathematical good exercise, but to be done with dam owner and sitting together. So I think its job is big, but not tough. It's a simple, but we have to develop the capacity in this direction. So that is also required. So I'm thankful to all the presenters, experts here who have given the presentations on different topics. And I'm thankful to the audience for having the patient listening. This was the last session. And after the lunch, so the topic was vibrating, as I said. So this kept you awake. Thank you very much. Thank you, organizers.
Thank you very much, sir. I will be requesting Mr. D.K. Sharma, Chairman, Himachal Pradesh Electricity Regulatory Commission, to please help us do the honors for presenting a memento to our chair and co-chair for the session. Can we have a round of applause for all the people on the dais, the presenters, our chair, co-chair. Thank you very much, sir, for weaving the session, for the insights to all the speakers, and for sharing your expertise. Our chair, Dr. R.K. Gupta. Our co-chair, Mr. Eric Halpin, former head of Dam Safety, USACE. Thank you, sir, for helping us out. I'll now request our chair and co-chair if they can kindly help us present a memento to all the speakers on stage, please. Starting with Mr. Shane McGraw from Australia. Mr. A. Shukla. From IIT Roorkee, Ms. Kavya S., WRD, Tamil Nadu. Mr. Shivdayal Bharati from IIT Madras. Second time I'm saying this wrong, MNIT Jaipur. Thank you for correcting me, sir. Mr. N.N. Roy from CWC. Thank you very much to our chair and co-chair. And I will request everyone if they can kindly join us in front for a group photograph before we wind up the proceedings on stage for this session. And for everyone else, we are approaching the end of the day and the two-day conference. We have a closing ceremony in which we'll be joined by the honorable ministers. So we'll request you to please be here with us. They will be here any minute. Thank you to everyone on the dais, please. We'll just get the stage set for the closing ceremony. Thank you, everyone. We will be starting shortly. We request everyone to please settle down. अपनी अपनी जगह पे please बैठ जाइए. I will request Ms. Debashri Mukherjee, Special Secretary, Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India, to please join us on stage. जोरदार तालियां हो जाए मैम के लिए. Mr. Saroj Kumar Jha, Global Director, World Bank. Sir, may we request you to please be here on the dais. Mr. Anand Mohan, Joint Secretary, Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India. Ms. Devashri Mukherjee, Mr. Saroj Kumar Jha और Mr. आनंद मोहन के लिए एक बार फिर से जोरदार तालियां हो जाएं प्लीज। और माननीय मंत्री जी कुछ ही समय में हमारे बीच में पधारने वाले हैं। हम आपसे अनुरोध करेंगे जिस समय वो यहाँ पे आए तालियों के साथ उनका स्वागत करें। The Honorable Minister will be here with us shortly for those who don't understand Hindi, and we'll request you to applaud his presence once he's here with us. Thank you. एक बार जोरदार तालियां हो जाएं please for the Honorable Minister Shri Gajendra Singh Shekhawat ji, who's here with us. Thank you very much, sir. देवियों और सज्जनों, विशिष्ट अतिथियों और सम्मानित प्रतिभागियों, इसके साथ ही हम जयपुर के बांध सुरक्षा पर इस ज्ञानवर्धक 2 दिवसीय अंतर्राष्ट्रीय सम्मेलन के समापन के करीब हैं। चर्चाओं, प्रस्तुतियों, भाषणों और विचार विमर्श के 2 उपयोगी दिन, देश विदेश के सर्वश्रेष्ठ प्रतिभाशाली दिमागों और सबसे समर्पित प्रोफेशनल्स के एक समूह के साथ, ये सुनिश्चित करने के लिए कि हमारे देश की समृद्धि के लिए हमारे पास सुरक्षित बांध हैं। Ladies and gentlemen, distinguished guests and esteemed participants, with this, we near the conclusion of this enlightening 2-day international conference on dam safety in Jaipur. 2 fruitful days of discussions, presentations, speeches, and deliberations, a gathering of some of the brightest minds and most dedicated professionals in the field to ensure that we have a safe and secure system when it comes to dams for the prosperity of our nation. With that, ladies and gentlemen, I think without any further ado, we are all set to begin the closing ceremony for the day. I will be requesting, first and foremost, Mr. Anand Mohan, Joint Secretary, Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India, to kindly present the conclusions and recommendations of the conference. Sir.
Namaskar. Honorable Minister Sahab, Namaskar sir. Madam Devasri Mukherjee ma'am, Special Secretary, Ministry of Jal Shakti. Our distinguished guest, Mr. Saroj Jha, Global Director, Water, World Bank. All distinguished guests from foreign countries, international arena, and all the distinguished participants from state governments, central PSUs. It has been great 2 days, very much overwhelming and very fruitful. Today I have been given the assignment to sum up the whole thing. There are certain key takeaways out of this 2 days conference. I'm sorry, sir, because of some last moment inclusion of some of the recommendations from some of the thematic sessions, we were a bit late. I'll go with a very brief presentation. The presentation comprises of certain details of the introduction of this particular work conference. Apart from that, we have a brief about the inaugural session, followed by the cultural programs in the place where we stayed. And plus, we have a series of thematic sessions for which I have the key recommendations and takeaways which we have listed. So I'll go one by one. Briefly, it will end in another 15 minutes. Next. ICDS 2023 is the first in the series of the Dams Safety Conference under DRIP 2 and 3 program. Prior to this, 5 conferences were organized under the first phase of DRIP. This conference has been organized jointly by Department of Water Resources, Ministry of Jal Shakti, Government of India, under the able guidance and vision of our Honorable Minister in collaboration with Central Water Commission, NDSA, Rajasthan Water Resource Department, MNIT Jaipur, WAPCOS, World Bank, and AIIB. Conference has brought together experts, technocrats, researchers, administrators, and professionals from around the world to exchange ideas, share experiences, and foster collaboration in the field of dam safety. Around 800 national and international delegates have attended the conference. We have got we have approved around 795, although we received request for registration more than 900. Honorable Vice President of India was the chief guest in the inaugural session. Sri Jagdeep Dhankar Sahab inaugurated the International Dam Safety Conference with the theme Safe and Secure Dams Ensure Nation's Prosperity. And that was done in the presence of our Honorable Minister and Chief Minister Tripura and many water resources ministers from almost 7 states. The key highlights of the inaugural session were flagging of the vinyl-wrapped Yeah, okay. No, ma'am, it was... Under the Kamakhya Express, under the name Pani Ki Rail initiative of the National Water Mission, that was a program which was plugged into this conference to amplify the message of water conservation. And in order to make that a small program, officers from railways, Indian Railways were also there with us.
unveiling of National Register of Large Dams, a compilation of large dams in the country, which was more than due on the part of Central Water Commission, that was also unveiled yesterday. 1 minute silence was observed to remember those who have been killed in Libya's deadly dam collapse. An exhibition was also organized on the sidelines of the conference, and the National Center for Earthquake Safety of Dams at MNIT Jaipur was inaugurated before the inaugural session in the early part of the morning by Honorable Union Minister of Jal Shakti. These are the glimpses of the inaugural session, and you can see those things which we witnessed yesterday. Now, coming to the cultural event which happened last evening in the place where we stayed, that was a nice evening. Now, coming to the actual series of the thematic sections, starting with the plenary session and the 8 themes which we have discussed in the 2 days, I'll go one by one. In this particular conference, we discussed 8 themes: dam health assessment, best practices on dam rehabilitation, reservoir sediment management, operation and maintenance and emergency management with respect to dams, lessons from dam failures and incidents, risk assessment, and dam rehabilitation techniques and materials sciences, which was meant for industrial session. Over 130 technical papers were received from central, state government organizations, PSUs, and technical institutes, and national and international experts. 16 poster paper presentations were done during the selected this conference. As far as the plenary session is concerned, the takeaways based on the discussion and the presentation of the participants in that particular session was where water storage are foundation to address the climate and water crisis and advance green resilience and inclusive development. This is something which came up. Sediment management needs to be given importance as we are losing significant amount of storage capacity for dams because of this big problem. We need to take individuals' responsibility to utilize water efficiently. Seeing the large number of dams in Maharashtra, this view came specifically from a state which owns half of the national number of dams. And this came from Maharashtra. They desired to establish the Center of Excellence of Dam Safety, which we will look into. The ministry will look into this issue. They also highlighted the issue of financial assistance for O&M and assistance to deploy the human resource to manage and actually have a upkeep institutional arrangement for the dams in the state of Maharashtra. The Dam Safety Act in a country needs to be reviewed periodically for amendments to keep up with the changing dam safety scenario. India, with enhanced partnership with the World Bank, can act as a model in the dam safety and water storage agenda for other countries, particularly the South Bloc countries. While seeking assistance from the external funding agencies, water sector should be given its due priorities by the countries. An international knowledge exchange program by creation of Global Large Dam Alliance in dam safety, maybe not in the immediate future, but maybe in the coming future, we may think about that. Now I'll go by one the technical sessions we had. This was the technical session 1, which was international and national practices in dam safety management and governance, which happened yesterday. The takeaways were strong governance structures are key to implementation and supervision of activities under dam safety. Risk-based dam safety management is an internationally accepted approach which assist in prioritization of critical dams for dam asset management. Risk control options in terms of risk prevention and risk mitigation measures shall start from planning and design state of the dams and shall continue through their operation and maintenance phases. Minimization of hazard potential of a dam should be a continuous exercise by continuously improving the emergency action plan. Design flood for deciding spillway capacity of dams shall be based on its hazard potential. And the last was the capacity building of all the stakeholders is essential for implementation of Dam Safety Act. More center of excellence and resource centers for dam safety are required to be established. Bear with me, there would be certain repetition of recommendations which came up in the other thematic sessions also. On yesterday, we had an industrial session, that was industrial session 1, and in that, what came up was regular monitoring and surveillance are critical and must be done for health assessment of dams. Cutting-edge instrumentation and technological interventions should be used for dam health monitoring. Dam safety reviews shall be carried out by an independent dam safety review panel and should be supported by studies and investigations thereto. Use of non-intrusive, non-evasive geophysical investigation and other advanced techniques to detect abnormal seepage, piping, and other health dam-related issues should be used. Today we had the first session, which was the technical session 2A, because we have a parallel session which went in the other hall. The 2A, which the session name, the name of this session was Best Practices on Dam Rehabilitation Case Study. In this particular session, the takeaway and the recommendations which came up were appropriate construction and repair materials and technologies should be used to rehabilitate the dams based on the need generated by the engineering solutions. We are using, sir, we have a word of rehabilitation, but we need to recoin some new word for that, suggested by Saroj Jha sir. Actually, we need to rename it as resilient program to make the dams more resilient. Dam owners should utilize the experience gained through DRIP in rehabilitation of technically challenged dams for successful dam safety management. Best practices of dam rehabilitation achieved under DRIP should be shared with all implementing agencies, for which a knowledge portal needs to be developed. National and international collaboration in critical areas of dam safety needs to be established. These recommendations were in line with what was discussed in the plenary session. The 2B, which was a parallel session today morning, the reservoir sediment management. In this case, we got the recommendations. Very important problem. Reservoir sediment management has become important considering the challenges in creating and conserving the reservoir storage. Regular surveys using latest technologies should be carried out, and repository of data on sediment surveys should be maintained for effective sediment management. Reservoirs should be designed for longer functional periods, and structural measures wherever feasible should be adopted for bypassing and evading sediments. Desilting of reservoirs should be the last resort. It does not remove the root cause of the siltation. Also, it is expensive, but has large detrimental environmental impact. Watershed conservation, inducing the catchment area treatment plants shall be a priority measure for reducing sediment yield and shall be taken up from the planning stage of the dam. Now I come to the third 3A thematic session. The topic was operation, maintenance, and emergency management. Operation and maintenance is a key factor in obtaining objectives for dams and reservoirs. Standard operating and maintenance procedures should be in place before initial filling, and that should be as per the provisions and the regulations in this regard. Periodic review of these procedures to incorporate necessary update. Robust emergency action must be carried out for minimizing the hazard potential of any dam due to breach or unregulated release of water. Emergency action plan is must for minimizing hazard potential of any dam. And very important, participation of all stakeholders is key for implementation of emergency action plan. And this must be supported by conducting mock drills, periodical mock drills. Regular training and capacity building of operational staff is also required for safe operation of dams, and additional storage capacity is needed for taking care of climate change patterns and the impacts thereon. The third session, thematic session which happened in the other hall, the lessons from dam failures and dam incidences. The key takeaways from this particular session was dam failure incidents should be thoroughly investigated. Learning from these incidents should be properly disseminated to all the dam owning states as well as organizations. Construction supervision and quality assurance should be strictly carried out during the construction and the repair phase of the dam. And the statistics shows that dam failure incidents in case of earthen dam normally occurs just after the initial filling, showing poor construction material and methodologies. Therefore, the initial filling protocols must be followed as per the manual and provisions of the Act. Dam construction agencies should be accredited based on their competence. And very important, more than 1,000 dams are more than 50 years. Why I'm saying so? 50 years is normally the life of steel as a substance, and therefore require regular maintenance, repair, and vigilant inspections with respect to hydromechanical parts, including the gates for their upkeep. The fourth technical session was about the risk assessment, and there were three suggestions from this particular session. The risk assessment considers the risk due to both normal and extreme events throughout the life cycle of the dam and shall be carried out periodically. Risk assessment should be carried out for all dams, including newly constructed dams. Now we need to think about and phase it out. Risk assessment is essential in prioritizing the critical dams and taking decisions on structural, non-structural, and then the preparation of emergency action plan and other safety measures. And the last session was the industrial session 2, which was on dam rehabilitation techniques and the material used for that. The recommendations which came here was integration of underwater inspection techniques and geophysical investigation for better understanding of the distress condition in the dam must be carried out for arriving at the appropriate remedial measures. Selection of appropriate repair materials and methodologies for rehabilitation works in a dam calls for proper dam diagnosis followed by field testing and laboratory testing. The decision to control seepage in dams should be taken judiciously based on geophysical investigation. What it missed here was that whatever material and whatever techniques we must bring in, there should be emphasis on Make in India. Thank you.
Thank you very much, sir, for that overview. Ladies and gentlemen, the closing ceremony would be incomplete without the insights, expertise, perspective, and of course, guidance of Shri Gajendra Singh Shekhawat, the Honorable Minister of Jal Shakti, Government of India, requesting sir for his words of wisdom. With a round of applause, ladies and gentlemen.
देखिए कैसी विडंबना है। ऐसे आदमी को शुरू करने के लिए कहा गया था जो इस सभागार में इस विषय के बारे में सबसे कम जानता है, और ऐसे आदमी को खत्म करने के लिए कहा गया है जिसने सबसे कम जिसकी उपस्थिति इस पूरी 2 दिन की कार्यशाला में रही है। ये तो अच्छा हुआ कि आनंद जी ने इतना डिटेल प्रेजेंटेशन किया, तो मुझे जो कुछ हुआ है उसके बारे में एक ओवरव्यू ब्रीफ में सुनने को मिला। लेकिन जितना पिछले लगभग 4.5 साल के इस कालखंड में इस मंत्रालय में काम करने और मंत्रालय में काम करते हुए आप सब लोगों से चर्चा करते हुए जो कुछ सीखा है, जो कुछ समझा है, डैम सेफ्टी एक्ट को जब हम प्लान कर रहे थे, जब हमने लिखा और उसके बाद में पार्लियामेंट के दोनों सदनों में पास कराने से पहले जिस तरह की तैयारी मुझे कराई गई थी, देवाशीष जी हंस रहे हैं, इन्होंने मुझे बिठा करके सब लोगों ने जो पढ़ाया था उससे जो कुछ मैंने जाना तो मुझे लगा, और उसके बारे में जो रुचि पैदा हुई, डैम सेफ्टी एक्ट के बनने के बाद उसके इम्प्लीमेंटेशन के समय में विभिन्न राज्यों के साथ में बात करते हुए उसके इम्प्लीमेंटेशन के डिफरेंट एस्पेक्ट्स और स्टेप्स, इन सब पे चर्चा करते हुए जब जो कुछ मैं समझ पाया, और पिछले इस 4.5 साल के कालखंड में दुनिया के अन्य देशों के प्रवास के समय में वहां की बांधों की सुरक्षा की स्थिति, डैम कंस्ट्रक्शन में लेकर के वहां किस तरह के प्रोटोकॉल्स एंड प्रोविजंस हैं, उनके बारे में जो चर्चाएं सुनी, तब मुझे कुछ लगा कि यह विषय निश्चित रूप से प्रासंगिक भी है और महत्वपूर्ण भी है। पिछले 2 दिन में बांधों की सुरक्षा के जुड़े हुए सारे एस्पेक्ट्स पर जिस तरह से हमने हॉलिस्टिकली बातचीत की है, इसकी महत्ता को प्रतिपादित करने के साथ साथ में इन सब विषयों से जुड़े हुए, इस विषय से जुड़े हुए सारे इसके अंग उपांग जितने भी हैं, उन सब के ऊपर जिस तरह से सब्जेक्ट एक्सपर्ट्स ने अपनी बातचीत रखी है, निश्चित रूप से मुझे लगभग 30 साल से ज्यादा का सामाजिक राजनीतिक क्षेत्र में काम करने का अनुभव है, और बहुत सारी कॉन्फ्रेंसेस में मैं अलग अलग पॉलिटिकल कॉन्फ्रेंस से लेकर के विभिन्न विषयों पर रखी गई ऐसी अलग अलग कॉन्फ्रेंसेस में जाने का मुझे मौका मिला है। कॉन्फ्रेंस के समारोह के सत्र में जो उपस्थिति अगर इतनी है तो निश्चित रूप से इस बात का प्रमाण होता है, इफ द वैलिडेटरी सेरेमनी में इतने सारे लोग उसमें पार्टिसिपेंट अगर उसमें हो तो शायद सबके लिए टेक अवे कुछ न कुछ है, और सबने उसमें इंटरेस्ट के साथ में हिस्सा लिया, ये अपने आप ही सिद्ध हो जाता है। सुरक्षा के डिफरेंट एस्पेक्ट्स पर हमने बात की, उसके सामने आने वाली चुनौतियों के बारे में बात की, डैम्स की डायग्नोस्टिक्स सुरक्षा के दृष्टिकोण से लेकर के जब हम करते हैं और उसको लेकर के जो हमारे सामने विषय आते हैं, जब मैं कल देख रहा था इनॉग्रल सेशन के समय में जब बातचीत हो रही थी, और प्लेनरी सेशन में, पहले प्लेनरी सेशन में जब जो पेपर मेरे सामने प्रस्तुत किए गए उनमें जिस तरह की चर्चा हुई, जो बांधों की सुरक्षा की चुनौतियां हैं उसमें से बहुत सारी चुनौतियां कंस्ट्रक्शन के टाइम पे जो न्यूनताएं रह जाती है, जो डेफिशिएंसीज रह जाती हैं, उसके चलते हुए होती हैं। इसलिए इन सब एस्पेक्ट्स पे बात करने के बाद में, क्योंकि आप में से बहुत सारे ऐसे लोग भी हैं सीनियर ब्यूरोक्रेटिक लेवल पर जो लोग काम कर रहे हैं, ये कंस्ट्रक्शन के टाइम पे रहने वाले गैप्स जो हैं, जो न्यूनताएं हैं, इस कॉन्फ्रेंस के टेक अवे के रूप में इसके ऊपर हमको एक पूरा डिटेल पेपर बनाने की जरूरत है। और हम जहां डैम कंस्ट्रक्शन हो रहे हैं और जो डैम डिजाइनिंग के लिए रिस्पॉन्सिबल CWC और उसके अलावा स्टेट्स में जो एजेंसीज हैं जो काम कर रहे हैं, एंड स्पेशली एजुकेशनल इंस्टीट्यूट्स जहां डैम्स डिजाइनिंग पर डिजाइन पढ़ाया जाता है, और प्रैक्टिकली फेलियर्स के कारणों को लेकर के, और जो हमने डैम डायग्नोस्टिक्स किया है, उनकी हेल्थ की डायग्नोस्टिक स्टडीज की है, उनको लेकर के जो हमारे अभी जो हमने इश्यूज को आइडेंटिफाई किया, उन दोनों को कोर्स करिकुलम में और इम्प्लीमेंटेशन दोनों में किस तरह से इंटीग्रेट कर सकते हैं, इसके ऊपर लॉन्ग टर्म प्लान हमको करना चाहिए। डैम फेलियर्स के बारे में भी हमने चर्चा की, उसको लेकर के भी डिटेल में और ज्यादा अध्ययन करने की आवश्यकता है, क्योंकि आने वाले समय में जिस तरह से क्लाइमेट चेंज के इम्पैक्ट और जिस तरह से रेनफॉल पैटर्न्स चेंज हो रहे हैं, उन परिस्थितियों में इस तरह के इंसिडेंट्स के बहुत ज्यादा बढ़ने की संभावनाएं सामने ऐसे दिखाई देती हैं। हमको और अधिक गंभीरता के साथ में इन विषयों पर काम करने की आवश्यकता है, और उसके साथ साथ में फेलियर्स और इमरजेंसी एक्शन प्लान्स भी। डैम के ड्रिप 1 प्रोग्राम के तहत हमने जिन डैम्स पर काम किया था और उनके जो EAPs हमने बनाए थे वो हम स्टेट्स के साथ में शेयर करें और उनको हम साथ साथ में नेशनल डिजास्टर मैनेजमेंट प्रोग्राम जो हमारा चलता है, जो हमारा उसके लेकर के जो वर्टिकल काम करता है, उसके साथ में शेयर करके हम एक जॉइंट एक्शन फोर्स ऐसा बनाए कि जो हमारी सब्जेक्ट एक्सपर्टीज है और उनको जो जैसे ऐसा कोई इंसिडेंस होने की स्थिति में जिनको उस पर काम करना, उन दोनों के बीच में भी किसी तरह का गैप न रहे, इसको आइडेंटिफाई करके भी इस पे काम करने की आवश्यकता मैं सोचता हूँ, महसूस करता हूँ कि होना चाहिए। बहुत सारे तकनीकी विषयों पर हमने चर्चा की है। सामान्यतः कॉन्फ्रेंसेस में हम बहुत गंभीर विषयों पे बहुत गंभीरता के साथ में चर्चा करते तो हैं, लेकिन उनको आगे अगले पायदान पर इम्प्लीमेंटेशन करने में कहीं ना कहीं कुछ न्यूनताएं रह जाती हैं। और मेरी अपेक्षा है और मैं चाहूंगा कि इस पिछले 2 दिन में हमने जो काम किया है, इस काम को हम किस तरह से प्रभावी ढंग से आगे ले जा सकते हैं, इसके लिए भी एक कंप्लीट स्ट्रेटेजी को दिव्याश्री जी, आपको और जो है आनंद जी, ऐसे सब लोगों को मिलकर के वर्कआउट करनी चाहिए। एकेडमिया को साथ जोड़ करके जो हमने इनिशिएटिव्स लिए हैं, चाहे हमने IIT रुड़की में जो कोर्सेज शुरू किए हैं, IDSC में जो कोर्सेज शुरू किए हैं, हमारे यहाँ जो MNIT में जो सेंटर स्टैब्लिश किया है, इस ताकत को हम और कैसे आगे बढ़ा सकते हैं। और ये जो इस कॉन्फ्रेंस के 2 दिन के डेलिब्रेशन से जो कुछ हमने नवनीत निकाला है, उसको इस एकेडमिक इनिशिएटिव्स जो हमने लिए हैं उनके साथ में इंटीग्रेट और कैसे कर सकते हैं, इस दिशा में भी हमको इसको लेकर के प्लान करना चाहिए। आप सब लोग आए, हमने बहुत गहराई के साथ में इन विषयों पर विचार किया और निश्चित ही जितने लोगों ने पार्टिसिपेट किया होगा, एक्टिवली पार्टिसिपेट किया होगा, उन्होंने कुछ न कुछ इस कॉन्फ्रेंस से 2 दिन में अवश्य पाया होगा। आपके अनुभव को समृद्ध करने में, आपके ज्ञान को समृद्ध करने में, आने वाले समय में जिस क्षेत्र में हम काम कर रहे हैं उस डोमेन में हमारे काम की एफिशिएंसी को और बढ़ाने में, हम और ज़्यादा अच्छे तरीके से काम कर सकें, इस दृष्टिकोण से हम अपने जो है असेट्स को और ठीक से मैनेज कर सकें, जो है असेट्स को मॉनिटर कर सकें ठीक से, इस सभी दृष्टिकोण से हमको कुछ न कुछ इस कॉन्फ्रेंस से मिला होगा। मैं आप सबको कि हम इस विषय को और गंभीरता के साथ में आगे ले जा सकें। देखिए, कुछ वर्षों पहले अगर डैम हेल्थ और डैम सेफ्टी इस विषय पर बात करते तो शायद ऐसा लगता था कि ये आउट ऑफ वर्ड कोई सब्जेक्ट है जिस पर आज बात हो रही है, लेकिन विद द टाइम it has become more and more, it has become relevant and it is going to become more and more relevant in the coming days and coming future. So हम सब लोग इस 2 दिन की इस एक्सरसाइज को और ज़्यादा समृद्ध कैसे कर सकते हैं, इस पर एक इंटरैक्टिव प्लेटफॉर्म बनाने के लिए भी हमने डिसाइड किया है। और उस इंटरैक्टिव प्लेटफॉर्म पर भी हम कैसे इन सब चीज़ों पे डिस्कशंस कर सकें, केस स्टडीज को लेकर फ्लोट करके, और उसमें जो इंटरेस्टेड लोग हैं वो लोग उसमें कैसे साथ में जुड़ सकें और एक दूसरे के एक्सपीरियंस से हम और ज़्यादा कैसे सीख सकें। दुनिया भर में होने वाले या हुए अब तक हुए इंसिडेंट्स के ऊपर भी हम कोई एक केस स्टडी खड़ा करके और उसके ऊपर डिस्कशंस एंड डेलिब्रेशंस को उस प्लेटफॉर्म पर, वेब प्लेटफॉर्म पर करें, ताकि इस सब्जेक्ट पे हम जितना ज़्यादा मंथन करेंगे उतना ही ज़्यादा हम जो है आने वाले समय में एफिशिएंटली अपने स्ट्रक्चर्स को मेंटेन और मैनेज कर पाएंगे। आप सब लोगों ने राजस्थान के आतिथ्य को मुझे लगता है कि बहुत अच्छी तरह से एंजॉय किया होगा, लेकिन कुछ भी न्यूनता अगर रह गई, कहीं भी आपको असुविधा हुई होगी, आवास में भी हो सकती है, भोजन में भी हो सकती है, कहीं किसी तरह की असुविधा हुई होगी, तो इस आयोजन के परिवार का मुखिया होने के नाते मैं आप सबसे उसके लिए क्षमा प्रार्थना करता हूँ, खेद व्यक्त करता हूँ। आप सब लोग आए, आपने एक्टिवली पार्टिसिपेट किया, इसके लिए आप सबका बहुत सारा अभिनंदन, खूब सारा धन्यवाद। लेकिन ये विषय समाप्त न हो, यहाँ से प्रारंभ होकर के हम इसे नई ऊंचाई पर ले जाएं, इस अपेक्षा और आकांक्षा के साथ में बहुत बहुत धन्यवाद।
Thank you very much, Minister Sir. I think everyone will agree with me this was a befitting conclusion to our discussions and a source of inspiration for the delegates who have gathered from all across. Thank you very much. This brings us formally to the end of this two-day international conference on dam safety. We extend our heartfelt gratitude to everyone who has been a part of this conference, who has flown from across the world to be here with us. एक बार आप सभी के लिए हमारी ओर से जोरदार तालियां हो जाएं, please. सिटी विजिट के लिए वी हैव अरेंजमेंट्स, उसकी व्यवस्था है, तो जो लोग भी जयपुर घूमना चाहते हैं, यू कैन कॉन्टैक्ट द टीम एंड दे विल मेक श्योर दैट यू कैन गो अराउंड एंड एंजॉय दिस ब्यूटीफुल प्लेस. Thank you very much. With this, I would like to thank everyone on the dais. एक बार जोरदार तालियां for all the dignitaries, the organizers behind the event, for doing, I think, an incredible job in making sure that this conference is a huge success. And इसी के साथ मैं आप सभी को आमंत्रित करना चाहती हूँ. I would like to invite you all for high tea, which is spread once again over 2 floors, which I am very sure now, by now everyone knows the area, but still, just for your information, on the ground floor, it is at the convention hall, and on the first floor in the multi-purpose hall. Thank you. With that, this is your host for the 2 days, and Charlie Arora signing off, wishing you all a great evening ahead, and those who are staying back in India or enjoying the city, a great time in Jaipur as well as in India. Thank you.